destroyed in Kharkiv region. Kharkiv city is destroy the civilian city every day by bombing it. Until February 24, as I said, Ukraine had the largest high-speed coverage internet in Europe. According to the statistic provided by the Ministry of Digital Transformation, 3 mobile operators lost around 11% of mobile stations. Around 12% of their subscribers lost mobile communication at all. Nearly 20% mobile communication remained slow. 25% of networks were damaged or destroyed. According to the statistics of World Bank, the losses of telecom is over 2.6 billion USD. They need around 710 million to compensate and to build mobile towers, to lay optical cables, to buy new equipment. They suffer from non-received subscription fee is over 100 million. Now you know more about our country, us and the situation we had for last 7 months. And now I will tell you more positive news. Just a month or something after the beginning of the war, we got a call from Natalia, who works for Association of Rights Owners in Ukraine. He told us, "Hi, I have been contacted from NLOG Alliance. They wanted us to help with telecom humanitarian aid and asked us to help with the customs, logistics, as well as with contacting the recipients and delivering the aid to them." So we started to make some papers for the first shipment, got some assist from the Ministry of Digital Transformation side, as well to pass the customs, and it was really great surprise for us when after 2 weeks we got the full truck filled with active equipment, servers, switches, SFP modules, and some other stuff. After the first shipment in April, we proceed with another one. Until now, we got 7 of them, just from the NLOG Alliance. This aid gave us an opportunity to help more than 60 companies. To be more exact, 69 within now. We help all 10 top internet operators in Ukraine, as well as small and medium-sized ones. There is no any criteria for us for the scale or quantity of subscribers to provide the help. Of course, the aid is delivered to the deoccupied regions or region which asked us for help, at the front lines and so on. Firstly, it was Kyiv and its suburbs like Bucha and Irpin. Later it was Sumy and Chernihiv. Just at the beginning of September, after the occupation of Kharkiv, we received many calls from there. After the occupation of Balaklia and so on, some operators moved there just to re-establish internet connection and started to provide their services again. Some numbers of NLOG Alliance help. Now the total help for the amount over 1 million USD. We received over 1,000 of SFP transceivers, over 1,100 switches and routers, 28 fiber splicers, a lot of wireless equipment. Just 2 weeks ago, we got 24 OTDRs from NLOG Alliance and already shipped it to the clients to test the fiber in the field after repairing their network. So after getting the aid from NLOG Alliance and successfully started this project, We got some help from other brands, like South Korean Inno Instrument, who provided us 10 fusion splicers, Latvian company Microtik, who provided us switches and routers for 20,000 of USD, or Chinese company who is the leader for PON equipment, who provided us help for 25,000 USD. We cannot tell that Keep Ukraine Connected is one project. It's a series of projects. Together with the Ministry of Digital Transformation, with the help from Elon Musk's side, we provided our ISPs and KTV operator Starlink, Powerwall gateway and inverter kits, solar panels, generators, inverters. Just in May, we got call from British Telecom from their Hungarian office, and they presented us 400 laptops. These laptops we already shipped to the call center of ISPs providers. One ISP provider made 4 internet classrooms in 4 schools near Bucha region. By the way, we use Wi-Fi kits from NLOG Alliance to provide Wi-Fi for free to children in these schools. We also presented around 100 laptops for the teachers in Hostomel, whose houses were completely robbed by Russian soldiers. We also presented laptops to people from Bucha and Irpin who also were robbed. We presented laptops to the refugees' children, and we continue this project as well. You can see the photos of happy people who is receiving laptops and starting using it. For all of us, all these projects were made under Keep Ukraine Connected motto. I would like to thank everyone involved in the project. First of all, NLOG Alliance team. It's René, Sander, Yen, Nestle, and volunteer driver Daniel and Martin, who delivered us 6 shipments, making 4,000 kilometers per road. If you want to listen to the story from René's side, you can find it easily in YouTube and hear how they staff their garages with some equipment, load the trucks, made some roads, and spent their nights in the border. I also would like to thank all the vendors who help us. Microtik, Inno, BDCom mentioned above, but I also would like to mention Juniper, Fortinet, Flex Optics. Thank you very much. Also would like to thank Natalia, who started this project and who is supporting this project all the time. Thanks to CES, the biggest satellite provider who provides the biggest donate to us, which help us to buy a lot of fiber splicings, a lot of TDRs, and hope to buy some other stuff in future. And of course, I would like to thank the Debs team, all the departments, sales department, logistics, warehouse, who continue to support this project. And of course, I would like to say thank you very much for the companies who donated own equipment and who involved in this project. Believe me that I saw the reaction of ISPs, and I can tell you they thank you very much. So despite anything, we continue it. We continue this project, we continue to fight, and we continue to provide the aid to telecom ISP providers in every region needed. So just now we need money funds to buy optical cable and passive components to repair the networks. We need to buy more fusion splicers and OTDRs, and we need donation for telecom equipment, switches, routers, SFP and Wi-Fi. So if you want to help, let us keep Ukraine connected together. By QR code, you can go to website of NLOG Alliance Keep Ukraine Connected project and find more information about the project. Thank you very much for your attention and keep Ukraine connected.
Thank you for your presentation, Dmitry. We are very honored to have you here live with us to answer a couple of questions. It is very understandable that we could all see and hear that at some points in your presentation you started to become a bit emotional. So my first question to you, I think, might be, how has your day been so far? Can you hear us now, Dmitry? No? Okay. In that case, maybe I want to ask Sander to come forward and tell a little bit about the Keep Ukraine Connected initiative.
So, yeah, my day's been fine, by the way. No, it's this all started because of René. Because René is the chairman of our foundation, and he actually drove with humanitarian goods to Ukraine, and then came back and was like, hey, we have this foundation to help network operators. Why are we not helping here? Sorry, Dmitry. So you know, it was just very simple. Like, my girlfriend's a designer, so she designed a nice logo. We put up a web page, and we're like, let's see if we can collect a few routers for them to help them rebuild. And then it got a bit out of hand. So yeah, we've had hundreds of people donating equipment. We have people driving all over Europe to collect equipment. The first truck you saw was actually driven by René from Berlin through Prague to Ljubljana in Slovenia, and then on its way back through Poland to the Ukrainian border. So he drove a few thousand kilometers in one weekend, first to collect all the equipment and then to drop it off. And people like Daniel, he lives in Germany, but I think he's almost in the Netherlands picking up stuff like every other. We try to collect stuff here for example, my parents have a nice covered place where we can store some equipment. So I just have to tell Daniel, there's another load of donated equipment at my parents, you know where they live now. And he goes and picks it up. So yeah, so it's been really crazy. Those fiber splicers are insanely expensive. Like if you want a good one that is usable for the backbone links, usually they cost about 10,000 euros. We have some really good deals with the distributors and resellers, so we usually get them for about half the price. But then that's still 5,000 euros per device, and like you see, we've shipped now 20-something devices that way. And all of that is paid by donations we got. So yeah, it's been incredible how much support we have gotten and are still getting. Teun.
Yes, I have a couple of questions from IRC. I hope that you will be able to answer them. The first one is, well, how do you get the stuff at the right place within the Ukraine? Because getting it to the border sounds doable. Getting it into the Ukraine sounds...
Yeah, so that's where DEPS comes in, and they're amazing at that. So what we do is either we drive to DEPS or we meet them at the border. The first shipment, they brought a truck to the first petrol station behind the border, and we brought the truck there and just put them back to back and loaded all the equipment from one truck into the other. And then DEPS takes it back to their warehouses. They package everything, they inspect everything, they prepare everything for shipping. And then they, because they're usually a distributor of like new equipment, they now for free provide all that service for the donated equipment as well. So it's DEPS that actually takes care of that and brings the stuff to the right place.
Okay. Next question, because I have a couple one. What are the minimum requirements for equipment donated?
So usually we go like if it's older than 10, 15 years, probably not. Minimum speeds are gigabit. We really don't need any 100 meg stuff anymore. Switches, especially if they have power over Ethernet, because they can be used to power the Wi-Fi access points in things like schools and bomb shelters. Basically, if you'd be embarrassed to put it in your own data center, don't try to ship it to us. Ukraine is not a third world country. They have a very developed internet ecosystem, so the stuff they need, especially for the backbones, are like 40 gig, 100 gig, stuff like that. They really don't need our old junk.
I think there's a nice list on the website as well, right?
Yeah, that's so basically not too old, gigabit or higher, and then usually we can use it. And of course, there's also stuff like KVM devices, out-of-band management, and all the other stuff. And of course, for that, the requirements are a bit different, but you get the idea.
Yeah. Okay, last question then from the IRC channel is, so where do we send the equipment? Your parents?
Preferably, we have Daniel in Germany and Marcin in Poland. They're the ones that actually also drive with their vans to Ukraine. So shipping it there would be ideal. Don't just ship it there, do talk to us first, because they have limited space available. If it's not possible to ship it, Daniel comes to the Netherlands a lot. So for here in the Netherlands, we do actually regularly arrange pickups. Either I pick it up and park it at my parents' house, or Daniel goes and picks it up, so we can arrange something. And if that's not possible, we can use some of the donated money to actually pay for shipping. But of course, we'd rather not do that and use the money for splicers.
Yeah. Okay, thanks.
Erik.
Oh, hey, Erik.
Hello. Yeah. So for the people in the room, if you have any equipment, please come talk to myself or to Sander, because we actually need to register you in the database. I can help out with that. Also, if you have any questions about it, for people living on the west side of the Netherlands, I have an office in Permanent. We can also use that for storage somewhat, and I'll make sure it gets shipped to Apeldoorn.
Yeah, just for everybody, Eric is our biggest promoter here in the Netherlands. He even paid for some booths at the MCH camp this summer. And please give him some applause, because he's been helping a lot. Sorry, had to do that. Do we have Dimitri back?
Well, we do still have him, but as you will have noticed, there is a problem with the audio. It sounds a little bit like last year, but believe me, the setup is totally different now, so it must be a different problem too. Anyway, Sander and Nathalie talk to him every day, so we will surely convey to him how everything went here today. And you can be sure that he will hear about this presentation and how it was received in this room. So thank you again.
Also, there are postcards and stickers around.
All right, then it's time for the next presentation. And I think the first one with Steven and Arjen already mentioned the upcoming IPv6 that was going to be so enormously great. I've personally been saying, but I am an optimist by nature, that if you would give the average household these days a connection that does only IPv6, that maybe it will take a few weeks before people notice that something doesn't work, because I believe that all the big things would work on that connection. But I'm not sure if that idea is correct, and to tell us all about it and verify my thought, here's André.
Hello, good morning. Yeah, my name is Andrzej Zaletka. I work for RipeNCC, and I'm going to talk about something pretty new, which is called IPv6 mostly, and it's a new-ish concept of access networks. That means I'm going to talk here about networks that people plug their devices into, not something on the backbone, but something like a Wi-Fi network here on this place or similar. The reason here is basically, yes, to give IPv6 a bit of cake and at the same time try to do something to get rid of IPv4 finally. So, yeah, we are facing this transition to IPv6. We already heard about that. We have trying to transition to this protocol for years and years. Oh, you don't even see the slides. Well, never mind. The slides are for me, so I know what I should be talking about. You should just listen. Should I wait?
Oh, you have them here.
I have it here, yes.
Let me check.
So hopefully in some moments, well, I will. No, well, anyway, I will just finish. The first few slides are just to set up the tone of the presentation, so it's not really. Is it anything?
Yeah, no. I don't think it's anything you can do. Well, we are network operators here, so I have to tell you that from this laptop, the slides actually go to the video crew over a network, not just a cable, but a network cable that has an IP address and everything. And this morning, actually before everything started, there was a little loop in that network. And since then, it doesn't really work very well anymore. And the people who can see the screen over there see exactly what is being shown on the stream. Oh. So that is not good. I'll just go back into the display settings here, but I think that this machine here is actually fine.
I can see the cable.
Yeah.
Ethernet. Can you try if internet works on this machine? Or something that is streaming it? Is this thing?
Oh. Yeah, it seems to. No, it's not.
Not really.
Yeah. Dit was hoe het moest zijn, dacht ik.
Is er iets met het netwerk veranderd of zo?
Nou, het draait ook niks meer door. Nee, opeens poef en klaar.
See what's new.
Sorry about that.
It's all right. I'm glad that I'm not the one running.
No, I know, this is a presenter if something like...
Things happen.
Nieuws, vertel eens een mop. You can do jokes or entertain?
There was something happening.
Steeds geen connection.
0 connections.
But if the internet doesn't work on this, then how can it?
It's streaming over IP.
Oh yeah,
Yeah.
that's the thing. Yeah.
Dit is die en die naar Phoenix Connect.
Ja.
Die streamt natuurlijk over IP.
Ja, maar deze heeft ook geen internet meer. Zie je?
Dat
Dit,
is sowieso...
Dit werkte wel gisteren.
Hij zat op wifi volgens mij, hè? Deze.
Nou,
Juist niet op wifi.
Niels
Nee.
zegt het nu ook, dat het netwerk... Anders moeten we nu de pauze doen, koffiebreak. Ja. En dan... bepaalde dingen. Nou ja, het lijkt wel het netwerk is wel instabiel.
Ja, dat was omdat er een link aan het klappen. Maar die is nu, die link is
well, I think we have an easy solution for this. We go for a coffee break that is a little earlier than planned. And then rebuild the network, or maybe put VXLAN on it or something, and then it should be fine. The coffee break was supposed to be until 11:05, so let's say that we see you back here around 5 to 11. There should be coffee, there should be cakes downstairs with a 20-year NLNOG logo on it. Enjoy.
exactly. And I told him that if you can cover as much as possible, then anything else, just let me know. I have my laptop. And how are you? Gonna have a talk? Oh, okay.
Sorry for the full
Yeah.
start. 25 minutes. We still go.
Yeah, I see. I see.
We take the original
It's fun.
program just to shift.
I'm happy to be here, to be honest. It's my first time.
Yeah, it's gonna be good. Yeah. Whatever you need, go do it again.
All right, welcome back, everybody. So the question, of course, is how many network engineers does it take to fix a network at a networking event? The question is all of them, indeed. The answer, we migrated the connection of this laptop from a Netgear switch to a Juniper switch, and now it seems to be working. I have one thing for everybody who came here by bike. There was one key found of a bike, and it can be retrieved at the registration desk. Oh, it can be retrieved from Thomas. Right. The earlier coffee break means that we have 4 presentations to go through before lunch, and there will also be one special announcement before lunch that is not in the program, but it will be there. So I hope you will sit tight and enjoy. I have already introduced him, so here he is again, André.
Hello again. I hope this time it will be a little bit longer talk than before the coffee break. So once again, yes, we are talking here about IPv6. Well, since the inception of NLNOG, the IPv6 was the topic, and it's unfortunately still the topic. It's not something we would do every day. We are still transitioning to it. The transition seems to be endless, because we are slowly deploying IPv6, but IPv4 is still the protocol of the internet, which is okay, except that there are not enough IPv4 addresses. I think we all know it here. And there are still some attempts to repurpose, 240/4, 127/8, or 0/8, all those talks, and all those articles about these things that actually get lots of hearts on RIPE Labs, which is the blog of RIPE&CC, much more hearts than articles about IPv6, by the way. So people will still think that probably repurposing 240/4 will help us. I'm not sure. It will just delay the problem a little bit. And we have transition mechanisms that are helping us running somehow IPv4 and IPv6 at the same time. There are many of them, but there are 2 worth mentioning regarding access networks, because they are special somehow. The first one is dual stack, and it's something that people don't really consider a transition mechanism, but it indeed is transition mechanism, which basically means that you are running IPv4 as usual, and you are running IPv6 next to it, and you are hoping that somehow the traffic will migrate to the IPv6 so you can turn off IPv4, but spoiler alert, it will not happen itself. The second one, which is a little bit more advanced, is called Net64, and out of all of other transition mechanisms, this one is the only one that allows unmodified end-user devices, sort of unmodified in theory, to access IPv4 resources. So it can allow network to be v6 only. we have this slide in our training courses that we talk about dual stack as the best transition mechanism. It's always the perception, because basically you have this IPv4 only that you always had, and you just add IPv6 on top of it. And so what can possibly go wrong? Everything will go well with IPv4. If there are any problems with IPv6, the web browsers introduce this little bit controversial algorithm called happy eyeballs that will try to switch fast to v4 if they think that v6 is not performing well. The biggest issue here is that it does not address the IPv4 address scarcity at all, because you just have IPv4 just like you had before. So by deploying IPv6, you are not solving this fundamental problem that there are not enough IPv4 addresses. Then there is this Net64, which allows us to deploy IPv6 only access networks, and at the same time have these networks sort of work, because not only native IPv6 word is accessible to them, but via this Net64 device, IPv4 internet is also available. In a similar way, Net44 makes IPv4 word available to private IPv4 networks. So it's not 100% accessibility, but it's good enough for today's internet services. In order to work, you also need DNS64, which is a nasty trick with DNS, which will make your devices think that everything is available over v6, because it will synthesize IPv6 addresses in the DNS answers in case the original resource only provides v4. It works very well. It's not a new technology. It's been around at least for like 10 years now. At RIPE meetings, such networks is available since RIPE 67, which was in 2013. And at FOSDEM, it's the default meeting network, for instance. It works very well, but there is this but sometimes, and you run into some things that don't work because they cannot work easily, and that is first, IPv4 literals. If you don't use DNS, then DNS64 cannot work, and then IPv4 literals has no way where to connect. Then there is this legacy software that is using IPv4 only software because somebody who programmed it learned programming network sockets in 1994 and didn't change their approach ever since. And then there is this also dual stack services which claim to be dual stack in DNS, but in the end the v6 is broken and it's masked on normal network because we have these happy eyeballs. So, but then again, there are already Net64 networks deployed very widely and mostly in mobile networks and mobile carriers, because they somehow choose to use this kind of network deployments. And they have also quite nice forces to mobile phone vendors, or also all equipments that have SIM cards in them, basically, to make them work it. So they were forcing all major mobile phone vendors to make them deal well with Net64 networks. And what those mobile vendors did is quite different in Android and in iOS. In iOS, it's much more interesting, I would say, because Apple didn't want to do any workarounds inside their devices, and instead they just say, well, we have full control over our Apple Store, so we can just force our app developers to fix their apps. And that's what they do. Since 1st June of 2016, they don't allow any app that would not work properly on Net64. They are automatically testing it. So every developer in 2016, it was like big problem for all the iOS developers, that they had to learn how the Net64 networks work and how can they test it, so what should they fix. But then again, even on iPhone, you have web browser, and with web browser, you still have option to put in their literal IPv4 address, and it should work somehow. So for that case, they developed this algorithm called Happy Eyeballs 2.0, which is like the Happy Eyeballs, but it also adds the thing that if you put IPv4 address literal in, it will somehow magically transforms it into Net64 prefix plus this IPv4 address. So it works somehow. Yeah, but then there is another case, and that you have your mobile that is IPv6 only, works very well, but you then turn on this mobile hotspot thing and connect your computer to it, and you expect the computer to work as well. And for that reason, actually, I think that's capitulation from Apple, because they just put their CLAT, which is the translation engine that basically translates IPv4 into IPv6 just in order to be translated to IPv4 back in the Net64. So it's some kind of like double translation, which, of course, as you hear it, you can basically find out that there are lots of corner cases where it goes wrong. But in general, it works good enough. So they use CLAT as well. They use it for tethering to a computer. Whereas Android got this easy approach and said, well, let's put that CLAT, and this will fix all the previous issues Windows have to deal with, forcing app developers to fix their apps, or doing like Happy iOS 2.0, all those things. So basically for both Apple and Android smartphones, IPv6 only is very doable and working. For desktops, it's a little bit harder. First of all, Happy iOS 2.0 is only in Apple. And in Apple, it's only in those apps that are using the high-level APIs, like Safari, but not in those apps that are ported from other OSs, like Chrome. So if you use Chrome, and you are v6 only, and you put the other IPv4 literal, it will not work. It will work only in Safari. In Windows, Linux, or Chrome OS, there is no CLAT at all, so you will still have this. I'm not saying that it will not work. It will still work very well, but there will be this but sometimes things which will not work. Very famous is Spotify desktop app that doesn't work over Net64, which I actually tested last week and it worked, so, but let's not spoil the story with facts. It didn't work for years. Then IPv4 literals, as I said, dual stack servers with broken v6. Yeah, and we have this Happy iOS, this legacy Happy iOS algorithm that is only trying to switch to v4 if v6 seems to go wrong. But then again, if you don't have v4, there's nothing to switch to, so it doesn't really help. Yeah, and then there is this VPNs, and most corporate VPNs are set up in v4 only, and it's usually just a configuration issue, but if you connect to v6 only network, it will just not work at all. So, can we do something about it? Because if we just keep using dual stack, the requirements for v4 addresses will grow, because the number of devices that people bring to networks is growing all the time. And even those more devices are like mobile phones that can do very well IPv6 only. We cannot easily distinguish them from the devices that would need v4 address to work properly. So, is there any way how to do it? And of course, that's why I have this talk. The answer is yes. There is this new thing, new RFC, which standardized DHCP option 108. It's DHCPv4 option, and the DHCPv4 option is called IPv6 only preferred. How exactly does it work? If you connect your device, like your mobile phone, into a network, the device will start looking for v6, of course, by sending route to solicitation, and also start looking for v4 connectivity by sending out DHCP discover. And in the DHCP discover, the device actually announces that it's discovering not only its IP address and all the thing, but also is discovering for option 108. And if the DHCP server gets this discovery request asking for option 108, and the DHCP server is configured in a way that it's aware that the network is v6 only capable, then the server will respond with offer of IPv4 address, but at the same time in the offer there will be this option 108 offered to the device. And once the device gets this offered option 108, it will think like, okay, so this network doesn't really need IPv4, so I will just stop here. The device will stop there, don't finish the DHCP transaction, and continue working on v6 only. So this way, IPv6 only capable devices like mobile phones can opt out from v4 whereas the network still supports v4 for legacy devices that don't ask for option 108. So those devices will still get their IPv4 address like normal. And therefore, you can have one network that has both dual stack clients and v6 only clients. And people don't have to select different SSIDs because if you ask people to do something, it's not going to work well. And also you have this opportunity that your DHCP pool will not grow in time because the number of devices that will need IPv4 will go probably down in time, not up. So this is what is called IPv6 mostly network that supports both v6 only and dual stack at the same time in one network. The question is this already deployed? And for my surprise, I did run a measurement during RIPE 84 in Berlin this year, and I found out that 2/3 of devices actually support it. They were actually requesting option 108 in their DHCP Discover messages. Basically, it's all new Androids, all new iPhones, and quite a surprise, also macOS devices. So from the device point of view, it's already ready. If you deploy IPv6 mostly network, you will save up to 66% of your IPv4 address pool for that network. Of course, this macOS thing, that is something that rings a bell because macOS is a little bit special in a way that it's still a platform that allows you a lot of freedom in a way that you can run very old legacy software that could be IPv4 only, and nobody will stop you from doing it. There's no it's not compulsory to use some app store. So how does this not break? Well, it turned out that in the newest macOS there is also CLAT inside, but it's very well hidden. And it only turns on by 2 factors. First thing is that DHCP option 108, I just talked about it. But the second thing you also need is that the NAT64 prefix has to be shared using array option that is called pref64. So, because the device, of course, in order to set up the CLAT, it has to know what the NAT64 prefix is used. And this pref64 is a way how you can carry that information as an option in router advertisement. So it's a little bit more secure than the previous version of Discovery that uses DNS64 using a special domain name IPv4 only.arpa. In a way that if somebody screws with your router advertisement, you have much bigger problems than just wrong configured CLATs. So it's not secured in a way that will be encrypted or authenticated, but secured that it's just sharing fate with other configuration parameters. Yeah, so in order to have your network IPv6 mostly, you need all these things together. So basically the network has to have NAT64, pref64, DNS64, and IPv4. Maybe, and if I play with this, you get this idea that maybe if you have NAT64 and pref64, you don't already need DNS64 because it should be sufficient. In theory, it is like it. But in practice, you need DNS64 for Safari and for iOS because those high-level apps on Apple devices will actually stop using IPv4 at all if they find out that the network is v6 only. So that means if there is this DHCP option 108, they will just stop using v4, and unless you have DNS64, the IPv4 will be invisible for them because they will not try to use NAT64 without DNS64. On iOS, well, I personally don't have an iPhone, but I heard from people that tried it that basically the CLAT is there, but it's used only for voice over Wi-Fi, so something like low-level system thing, but not any app that you use on the phone itself. And in this network, you also need IPv4, of course, because that's how the legacy devices will work. Now, that's basically the main point I was going to talk about here. Now, a few of my experience of running IPv6 mostly network from my own perspective. First of all, you need the DHCP option 108. This is very easy. First of all, there's native support in Kia. So if you use Kia as a DHCP server, it's just configuration. But the nice thing is that there is no special requirement for special processing on the server side. So virtually any DHCP server that supports custom options can be set up to provide the option 108. There's just option 108 with 4 bytes of one number that is telling the client how long the IPv4 stack should be deactivated. So you just put there like half an hour. And that's it. The only thing that is a little bit surprising is that you need to have some pool of IPv4 addresses, because if the IPv4 address pool is full, then the server will not respond, even if in the end there is no need for any address to be assigned. So there still need to be some addresses in the pool. With pref64, which is the option of router advertisement that will share the net64 prefix, it's much harder, because in general, routers don't allow custom array options in their configuration, so you need to have your firmware of your router upgraded to support this option. And that's like really stupid, because we already had this problem with recursive DNS server option, which was standardized much later than the array. And we have this problem again, and we'll probably have this problem again and again and again. So the only thing that you can now use is if you use some software routers. There are patches. There is patch for RIDVD, there is patch for FRR, and there is patch for ODHCPD, which is used in OpenWRT. Most of them are not merged, so they are merged or not released, so you have to compile the bleeding edge software. And the last thing is, I gave it a try, and I found some interesting surprises on macOS, which I would like to share. I also reported them to Apple somehow, and I got confirmation that they are tracking them internally. So hopefully before these networks are really deployed, this will be fixed. First of all, if the CLAT is set up, which is in this gray area, it just chooses completely randomly a IPv6 address that is used as the outside address of the CLAT. It will use ULA address if you have it in network. It will use even deprecated prefix if you are announcing 2 prefixes for, let's say, quick switching between 2 prefixes. It will just use whatever is there, and it does completely random choice, which is probably not good. But it's not causing big harm if your network is very simple. The second thing is that if you have your configured custom DNS server using IPv4 address literal, somehow the operating system resolver is not able to use the CLAT engine inside, but the utilities like host or dig will use them. So here you have example that I have 4 ones as an name server. I can use command host to resolve google.com, but if I try to ping it, it will just tell me unknown host because after timeout, because it just cannot reach IPv4 literal DNS server. So that's a little bit hiccup that can be easily solved by turning off custom DNS resolvers or setting them up for v6 address. And the last, and I think the most serious thing is that somehow, I don't know the reason, whenever the CLAT is active in macOS, it will influence the ordering of the getOtherInfo system call library, which is the library code that is used for resolving domain names into IP addresses. And the order is actually the order the thing that is trying to connect should use to try first and second. And somehow, IPv4, even though it's going through the CLAT, is preferred over IPv6 in dual stack servers. So if you are connecting to dual stack server with some app that is using getOtherInfo, which is basically every app except for web browsers, it will prefer going through CLAT and NAT64 than going natively via v6. So this may have a bigger impact on the stress of NAT64, and I really hope that this is something that is going to be fixed soon. That's basically it. I hope it was not too overloading. I have some pros and some cons at the end, so I can just, you can already see what the pros are, that basically you have only one network, and you don't waste IPv4 addresses for devices that don't need them. And even the dual stack clients, the legacy devices, still like use the minimum of the IPv4 because there's still DNS6.4 in the network. So all the apps that are capable of v6 will go via DNS6.4 and NAT6.4, then going directly over native v4. The problem is that the most complex network you can set up, basically, because it's dual stack plus IPv6 only, both in the same time. You still have to deploy IPv4 there, so yeah, you don't have like immediate saving on IPv4, and you still need NAT. In this case, NAT6.4. But if you're already using NAT4v4, then replacing NAT4.4 with NAT6.4 is not a big improvement, I would say, if ever. And then, of course, there are some baby issues, like if you have such network and you connect your Chromecast, which is running on dual stack, with your Android phone that is running on v6 only, they can just not communicate with each other. They just say it's impossible to connect. And that's it from me. And I would be happy if you have any questions. If you can come to the microphone.
I think there are questions on IRC, and if you have one when you're here in person, then please go to the microphone and state your name and ask your question.
I have a question here via IRC from Tijn. He's asking, what is the status of the support of the DHCP option on other operating systems like Windows and Linux?
Windows doesn't support it yet, as far as I know. Linux, Linux offers you freedom. So, for instance, in DHCP, my favorite DHCP client is called DHCP CD, and it supports it. But of course, you just configure it to support it. It will support it, but it will not do any other magic like setting up a CLAT, or you have to do it yourself.
Thank you.
Hey, just want to thank you for the presentation. I'm really surprised to see that macOS now has a CLAT, and I think that's great news. And yeah, if they can fix the outstanding bugs, that would be really useful for the future. So thanks.
Thank you.
Hi, I was just wondering what's stopping anybody from injecting DHCP option 108 packets or messages to clients if they are just going to shut down IPv4?
Nothing.
Wouldn't that be a vulnerability then?
Well, if you are able to inject DHCP replies in any network that is running v4, you will break it. And just injecting 108 is one of the myriad of options how to break it. Basically, securing network against rogue DHCP servers is a very basic thing how you secure access networks. So I don't feel there is any new attack vector in this.
Okay, so it's an acceptable risk. Okay, it could be interesting to troubleshoot, actually.
Definitely.
Hi, so earlier it was mentioned that Windows and Linux don't yet support the 108 option and or setting up a CLAT. Is there any future outlook that maybe they will in the future? Or
that's a really good question, but not for me. I have no idea.
That's unfortunate. Thank you.
We have to ask Microsoft. We have to ask others. Yeah.
Thank you.
I talked to Jen Linkova from Google, who's very excited about this, and she was telling me something that Chrome OS should have supported it at some point in time.
Okay.
We have time for one more from Arjen.
I was wondering, what is the idea behind the time that you switch off the IPv4 stack?
You mean the time and the option on 108, how long it should be suppressed?
You have to give a time, and it switches off the IPv4 stack during that time. For that time. I have no idea why, and also, what happens after that time? I know it switches on again.
Well, my guess is it sort of follows the way how DHCP works in general, that you get leased addressed for a time, and after a time you have to go ask again whether you still can use it or whether you can release it, and this is the same thing. So basically, you are asking not for address but for configuration, and you get information that you should stop asking for address for half an hour, and after half an hour you come back and ask, is there now IP4 address for me? And they will just say no, still not.
Okay, so
I'm not really sure whether it's useful in any way, but yeah, that's how
So it follows the paradigm of DHCP.
Yeah, it seems like this is like permanent thing. It's not like the network would switch from this setup to a different setup within minutes.
Okay.
Thank you, Andre. We have a small present for you.
Oh yeah, just one more thing. I have just before I end, I have just this small thing that my colleagues were asked. We have this running this survey. Oh, you don't see it anymore. The survey about NOG participation. So since this is NOG, we would really like to
Please
you to participate.
scan the code now.
Scan the code now. Yeah.
Fill it out.
Thank you very much.
Before I give the floor to the next presenter, I would like to ask Sander to come up again, because he has been in touch with Dimitri in the meantime, and with audio, I think. No chat, okay. And he just wanted to convey a message.
Yeah, so Dimitri he saw the videos and he was very happy. He said, I just wanted to congratulate us on the anniversary. And despite all the sadness we have each day, seeing the logo today, he wanted to say, make love, not war. And he said that they really miss the peace, the leisure, and the safe days. So, but he wanted to congratulate us on the anniversary and express his gratitude.
Good. Means I can close all the troubleshooting terminal windows on this machine and find the next presentation, which is over here. The next presenter is already there, so that's good. This will be a little less technical and a little more policy and maybe financial. So it turns out that there are telcos who want money. Who can believe it? Rudolf van den Berg is here to talk about it.
Yes, thanks. I'm a bit of an odd one out here because I don't actually run a network, so I'm not a network operator. I'm sorry. I never was any good at it, but I had a lot of bad friends in university who took me over to the dark side, basically this. And I have a degree in public administration, but I deal with telecom stuff all the time. That's what you get when Remco van Mook and Herke Plantinga and people like that buy a lot of beer for you. And so this is me. I'm a consultant at Stratix. Stratix is a small consulting firm in the Netherlands that for over 30 years has been doing telecom policy and all kinds of related stuff in the Netherlands, pushing fiber to the home. I've worked at various places. I've basically seen almost every side of how a telco works and gets regulated. I started my career at the Dutch-German Internet Exchange, where my first presentation was at RIPE 2001 in Prague, and the first person responding was Rüdiger from Deutsche Telekom, telling me that this was the dumbest idea he had ever heard in his life, to start an internet exchange in the Netherlands and Germany at the same time. And I didn't know who the man was, so I said, well, sir, if you have a network in Germany, then maybe we should talk about cooperating and how I can use your fiber to get to a better place in Germany. Everybody laughed in a room of 500, 600 people, and I didn't know I had made a joke. There is a disclaimer to this presentation. It is ironic. I generally speak in an ironic way. Unfortunately, this isn't always recognized. Today I will be ironic and sometimes even sarcastic. To give you an example, me attempting irony about the T-Mobile routing incident in 2019, I stated that all these small networks, including Gin Distillery, Meany, and some other people who are probably here, were irresponsible and failed to call their favorite Deutsche Telekom salesperson to fix their interconnection, which of course everybody in Germany knows that you should do. Unfortunately, in a report for the Bundesnetzagentur, somebody missed the irony, and it says the smaller players did not do this and could no longer reach Deutsche Telekom's customers. I apologize for this. Disclaimer, I also don't dislike telecom firms or their staff. I like telecom firms, I work a lot with them. I'm the program manager 5G for the Dutch Association of Municipalities. I worked really well with Dutch mobile operators and the Dutch government on getting, example, antenna policy, small cell policy, contracts, etc. We now have a uniform set for 340 municipalities that they can just copy and work from, and I hope it makes life for everybody a lot easier. I also deal a lot with Etno, who is promoting this whole idea that people need to pay. But they're also nice enough that when I raised an issue about 112 not being reachable over VoLTE, etc., that they actually got somebody on it and were really positive about it. So it's great to have debates about one issue and to disagree vehemently, but to work together on something else. If you know anything about VoLTE or voice over new radio, etc., and all the troubles it has, please talk to me. Anyways, 17 big telcos are very clear. We need to get paid more. The CEO said so it's still a bit dubious who can more, but anyways, their economist consultant said that they need more, about 15 to 36 billion per year from tech giants. That's a lot of transit. But, you know, it said so because that's needed for a sustainable internet ecosystem in Europe. And, well, you know, they said it before. They've been saying it since 1996. I actually found meeting minutes from my old employer, the OECD, from meetings they had in 1996, where the internet was, according to people, too US-centric. And up to 15% of transatlantic IP traffic was DNS. And this was insane. And should change, and the American .com firms should pay for that traffic. In 2001, they had a meeting where Telia said that you couldn't build an IP backbone for IP transfer for best effort because that's not a viable business. Deutsche Telekom talked about the flat rate fallacy, and they wanted risk-sharing models because it was so hard to build networks and they had to carry all the investment risk, and somebody needed to pay for that. For any Germans present here, the same person still works at Deutsche Telekom, but he said that incumbents have incentives to offer local interconnection services for internet services. So maybe you might be able to quote that back to them. Then we had, of course, the GSMA. We needed something to avoid degraded quality. And then Etno in 2011 wanted sending party network pays. That actually caused me to organize the BEREC OECD meetings on IP interconnection. I then worked at the OECD, which is an organization of countries, and I noticed that regulators in Europe and elsewhere didn't know peering people, and I just knew quite a lot of people who worked in peering. And so even though it was a right meeting in Rome, we got people to fly from Rome to Brussels to talk to the regulators. It was great fun. Again, Deutsche Telekom said that they needed an adequate return, which needed sending party network pays. Alcatel-Lucent said that content peering leads to a net loss in revenue for the internet economy and ISPs. There was an EU project that said that we needed a fair distribution of revenue share and QoS in networks. And fortunately, the European regulators weren't convinced because there were, of course, also some of you and peering coordinators, etc. And they explained that it all just doesn't work like this. So that was great. But who are, at this moment, because they said, well, telcos are right, the biggest content generators need to pay. Who are those? Well, it just so happens that I looked in my Windows Task Manager and I loaded some websites, and it's beautiful. the Ethno website loaded at my home over KPN at 112 megabits per second for a second. It was the highest I could get. Telefonica 50, KPN 15. I have no idea why, but it's beautiful. Amazon was like 50. You know, compared to normal streaming services, who's using the network more? And of course, you need to look at networks on a, well, less than 1 second level, because 5-minute averages, then it just smooths out everything. And then if we then look at who profits from the network, when I was on the faculty board in 1995, we saved 30,000 guilders just in the first year of having email, because professors didn't send their papers around with postage anymore. That was a massive saving on the budget. The Dutch central government, because of all the networks, reduced its energy use by going to 4 data centers by over 100 gigawatt hours. Well, the Dutch tax service doesn't need paper anymore, basically. And magically, telcos are posting better profits, higher guidance. What I try to explain to regulators, what I try to explain to people who don't understand networks, that you don't build a network for traffic. You build the lanes, but the traffic are the cars. The traffic is the fill rate. The network keeps on sending all the time. Sending more traffic on a 10 gig link just means that there's more information in those bits. But the thing just keeps on popping signals back and forth, whether they have meaning to you or not. And of course, you can saturate any network, but that's not the case actually in most networks. So what you want is a very wide road that everybody can just drive on. And of course, speed is a nonsense term. Stuff doesn't go faster on a network. It's the speed of light. And Einstein had something to say about that. Actually, when we look at networks that carry the most traffic, as in some kind of meaningful data, it's probably cable networks, I think. Because they continuously broadcast a DVB television signal, whether you want to watch it or not. Over 100, 200, 300 channels just keep coming to your home. If you look at that on a per gigabyte scale, that's a massive waste of bytes. We should do something about that massive waste of bytes. And you know, there's this, well, Deutsche Telekom is getting a bit of a bad rep, but that's also because they did a lot of work around this and they are very quotable. They got somebody in 2013 to design their new network, Peter Lofberg. Some people may know him. I never knew why they invited him, because the guy got his mother like 10 gig or something in 2007. Oh, 40, I'm sorry, yes, 40 gig. So you get a guy who just designs a network that's way too large. So basically he designed the network in 2013 for Deutsche Telekom. It allows everybody to watch the World Cup final in unicast 20 megabits, because per 250 users you get a 10 gig, that's 40 gigs per user, and then you do 400 gig of uplink. Except of course, that's basically how everybody builds a network. We recently helped the Dutch Student Housing Organization, and some of the people here even tendered for it. Of the 8 proposals, 6 people just said, well, here's 10 gig per 48 ports. So 40 students on a port, and well, 250 megabits, that should just work, and then 4 times 100 gig uplink, and they should never have any trouble with that traffic at all. And of course, Nokia makes switches. This thing is advertised as doing up to 432 terabits per second, and well, all of France does 43 terabits per of interconnection, which I will show later. So this thing is a bit oversized. When you look at it, traffic just isn't surprising. Telcos aren't really willing to publish stuff about their traffic, but every now and then they do. And, well, in the US, 4 megabits per subscriber. There's a really nice ISP here in the Netherlands called SKV Veendam. They have one network in one town. They have 90% penetration. They have about 10,000 customers. They have no peering. They just have 2 times 40 gig uplink. But it makes it really easy to calculate what's happening on their network. And here you see they do 26 gigabits per second when the Formula One played. And that's 2.6 megabits per household on their network. Of course, they have DVB-C, so TV is a bit less. But this really shows that a normal Dutch town, what they normally use. KPN proudly announced to the world that it did about, well, I calculated with pixel peeping, about 2.5 terabits of peak, extra peak because of the Formula One at the same time. But also just basically saying, yeah, that was something that was peanuts. We handled that with ease. If you then think of SK Telecom in Korea saying it couldn't handle 1.25 terabits for Squid Game, you really wonder who runs the network there and if they have a network operators group. BT says it does 28 terabits for the whole firm. And despite the CEO saying that, well, that might be unsustainable, people like the network team gave presentations to investors saying, yeah, that's no problem, we can handle that with ease for years to come. KPN now actually has an offer on the market in the Netherlands approved by the regulator for access to its network where it calculates that an average user will use 5 megabits per subscriber and 21% growth per year. So, heck. There are some telcos with serious problems. Again, the same firm, I'm sorry. They complained that they had to do 357 terabytes per day of YouTube traffic. But they have 51 million customers, so that's 7 megabytes of YouTube traffic per customer per day, which fits on those 5 floppy disks. And the only thing I can think of how this might be unsustainable if they actually use the 5 floppy disks to transmit it to their 51 million customers. But, you know, they're now building a 5G network that will allow self-driving cars and remote surgery and I don't know what else. But how they are going to do that in 7 megabytes per customer per day, I don't know. Then, of course, we have British Telecom. They're pretty nice people and they give nice presentations, also to their investors. And this is what they say to their investors. Hi, this is our network in March and April 2020 and now in 22. And COVID caused a lot more traffic on our network, but not a higher peak. And we don't really care about traffic, we care about peak. So yes, it was more gigabytes, but it wasn't really a lot more gigabits. It was just spread out more over the day. And well, we see that with other things as well. It's more spread out over the day. So it's a bit like saying, well, people drive more during the day over longer distances, but that doesn't mean that they all come in at the same time. And of course, much of traffic should be handled locally. The same BT a couple of years back in 2018 said, yeah, we have about 10 terabits of traffic on our network and about 5 or 6 we handle through CDNs locally because that saves a ton of money. And then we do a whole lot of peering because that saves money, so we're really, really happy. In the past, there were other policies, of course, internet exchange policies. I found a great policy from 1998 where INEX, but also links, required you to connect to May East and May West and places such as that, or to have a connection to a root server, I don't know. So yeah, at INEX, they had to laugh when they saw this one coming by. It was in an old paper. And of course, telcos say that they don't get paid for traffic, but they almost charge everyone. And the experience in Germany is a really nice one. And I got this from Deutsche Forschungsnetz themselves. So pre-COVID, this was their network design. They had 2 upstreams, transit. They had a whole bunch of interconnections. And then they were connected to JA, all the other academic networks in Europe. And they were more than able to handle their traffic. They had around 1.1 terabits of capacity. Then COVID hits, and all those students go home. And all of a sudden, the students complain that they have 20 to 30% packet loss on a 30 kilobit link to their university. And somehow they can't follow classes as a result of that. But this is only basically students who are on Deutsche Telekom. And then Deutsche Forschungsnetz goes talking with all the German ISPs. And magically, almost everybody agrees to a direct interconnect. So you see a whole lot more direct interconnects, also to German ISPs, 100 gig here, 2 times something there, except for Deutsche Telekom, who said either you can pay us far above market rate for what they call transit, but is just a private network interconnect, or, well, you know, those students can say their career goodbye. And the DFN had to pay, and they still pay. This is the current situation. They have about 2.2 terabit of capacity. Their Deutsche Telekom link is not full, by far not, but they have to pay. And this happens to basically everybody in Germany. If you want to send traffic to Deutsche Telekom, you pay. Not because your network can't handle it, not because their network can't handle it, because they actually advertise that their wholesale network has 80 terabit of capacity. So how the hell they have trouble handling small streams of traffic like those from the Netherlands, nobody knows, except maybe if you see it as a way to entice people to pay for something that doesn't actually cost money, because all you need is a yellow rope of fiber. And well, in France, the French regulator collects statistics. The total traffic in France last year was 43 terabit. There's a lot of traffic, but you know, it fits on a single switch these days that Nokia sells, so it's not that much. But there's some in France that don't do any peering. Well, actually, a lot of them. It's only 2% of traffic in France. CDNs is only 17%. You saw BT, they did 60%. And most of it is in Paris, which is just crazy that you have this massive country and everything has to flow through Paris first to get to a consumer. I heard it's as bad as that traffic arriving in Marseille from Asia first goes to Paris and then back to Marseille. Particularly what we've now learned from the Ukraine about why it's good to have 19 interconnection points in your country and why that provides resilience. This is something that regulators could look at. Also the Korea situation. Anybody know where the Koreans do their peering, their interconnection? China and Japan. That's like peering from here in Helsinki and Athens, because, you know, we're in the Netherlands, so the logical location to peer is Helsinki and Athens. And then they have this big sea and anchors, and well, since this week, we start worrying about people breaking stuff in the sea. So surely all that traffic should cost a lot. Oh, sorry, I see I'm over time. Well, France really has the best telecom market. I once gave a presentation about it, why all telecom product management is wrong. Can you believe it's the French that get it right? This is Orange. They have an excellent offer, which does 2 gigabits and a whole bunch of stuff. It costs you 35 euro per month. It's included with television. It's included with unlimited calls to like 100 countries. You can have a lot of fun. You even get a couple of things. So to conclude, really, this should be the last time EU telcos start this debate. For 25 years, they've been saying the same thing. Basically, it always starts, it's the Americans. Now, a lot of things are the Americans, but I don't really think that this is it. Particularly not now when we have all those streaming services with sports in Europe that do massive amounts of traffic, or European gaming firms, etc. So, nothing to support their claims. Please let it stop. On the other hand, I do make my money from it for the last 20 years, so maybe in 10 years again.
Thank you, Rudolf. It's yeah, questions. Well, we may have time for one question. So Teun or Blake, whomever.
Okay, so the question here is, isn't it just that telcos miss their insane revenues from SMS and calling minutes that they want money from the content networks now?
Yes, no, maybe, because, you know, yes, in France they pay 35 euro per month, so that's madness, but in Germany they pay 75 or 80 for less, so, yeah.
Sometimes ironic.
Blake with Zayo, thanks a lot for this. What do you think are the chances, more or less, of the NLNOG proposals getting traction in the European Parliament?
Well, it's all about how you explain stuff to people. If you talk about big numbers, terabytes, nobody understands them, it sounds like a lot. If you talk about Americans, and if you say, well, it's 50% of traffic, it sounds like a lot. If you say the European Commission's website will hit consumers with 70 megabit, it now hits them at 120 megabit, a normal stream is 10 megabit, they look at you like, that can't be true. If you then explain them that the average traffic per household is 2.5, or in France, well, interconnection is 1.5 megabit per household in France at this moment, and you sell 2,500 megabits for 35 a month, and then you complain that you can't handle 1.5 megabit? Well, maybe you need to go to the local network operators group, NLNOG, and see if you can find some competent network engineers. I do think that one of the major problems is in some telcos that their wholesale department sets the internal price for traffic. And if I was the head of a wholesale department of a major telco in Europe, I damn well would price it at 5 euro per megabit because my bonus at the end of the year would be guaranteed. But that's not necessarily market price.
Thanks.
But it does explain why some people in their organization then think that traffic costs money.
Well, regardless of that, we have a small bonus for you anyway, Rudolf.
Thank you.
A few years ago, we held a camping event, NLNOG Camp. I will be honest, I must say that I left the camp one night early. The reason was that I was a bit unlucky because I had brought a tent that I used maybe 20 years earlier. And when I unpacked it, it did not have the poles, so there was no way to put the tent up. So I bought a new one pretty quickly. And then during the night, I also found out that the air mattress that I was on was leaking. So I was on a flat grass floor in the morning. Natalie told me that I should be the one to receive the baker to get all the fresh bread in at like 6:15. So the camp for me was not a big success, but for whom it was a success was Rinse, because he presented about fiber to the, was it also farm at that point already? Fiber to the farm. Right now he's taking it up a notch and he will be presenting about fiber to the country. Here is Rinse Kloek.
Thank you, Niels, for the introduction. You spoiled my introduction, but nevertheless, 4 years ago I did a presentation. It was called Fiber to the Farm. I held it during the NLNOG camp. You see a picture here, and I also showed this picture during that presentation. This is the farm where I was born 42 years ago. This farm is still in our family. My brother took over. And I am a bit jealous at my brother. Not about that fact he has to get up every day at 6 o'clock, milking cows every day, 365 days a year. But 1 year after the presentation, Fiber to the Farm, he got his fiber to the home connection. So while I still had a lousy DSL connection of only 20 megabits, and I was living in an urban area, he was living on a farm, and he had even a gigabit Ethernet connection, fiber connection. So yeah, I was a bit jealous, but things are changing, and I will talk about that. The topics. First of all, I will tell you something about the current status of the fiber rollout in the Netherlands. Where are we and what is going to happen? Then I will tell something about the techniques that are used, XGS-PON and point-to-point. Then something about XGS-PON, some more technical aspects, a technical deep dive. I had to cut it out a bit, otherwise I would talk for 1 hour. Then something about activation process and about the automation I created. And last but not least, we have some time for some questions. First, something about me. My name is Rinse Kloek. I'm currently a freelance network engineer. I'm in the business for 20 years right now. I started my career at Solcon, where I grew up and learned a lot of things. Thanks for that. And also I'm a proud owner of all different NLNOG t-shirts. I've been to all NLNOG days, starting from the beginning. And currently my project I'm doing, the first project is the project at Delta Fiber. Delta Fiber is a merger of Kaiway and Zeelandnet, Delta. And Delta Fiber has a very big ambition. They are building a new Delta Fiber, fiber to the home network. And they have a target of building 2 million fiber to the home connections in the coming years. They have also 2 big investors. They are investing more than 2 billion euros, so that's pretty much money. So yeah, you can do something with that. This is the current status of the fiber to the home rollout. Current, it's of 1 year ago. Rudolf, thank you for lending this picture. It's from the website Breedband Atlas from Stratix. The only thing is of 2021, so it's 1 year old, so maybe you can fix that. What you're seeing here is the hotspots are more in the eastern part of the Netherlands, so more the rural parts where there are a lot of small villages, farms also. And you see also around 2 hotspots. One is the region in Overijssel, Rijssen, and that reason is the headquarters of Reggefiber, who was one of the first big investors in the fiber to the home. It was located in Rijssen, and all regions around Rijssen have fiber to the home yet. And also around Eindhoven you see a hotspot. I think that has something to do with lots of innovation, a lot of projects started around that area. But right now, all projects all over the Netherlands are popping up. So from the east to the west, north, south, everywhere there's fiber rollout. Yeah, now something about my own fiber connection, fiber to my home. That started last year during the summer. The first steps were, they're laying the city ring ducts, so the backbone fibers are laid under the sidewalks, so the connections to the different area pops. 1 month later, they arrived at my home, at my driveway. And actually, they don't need to open the driveway. They use some special drilling technique. It's called a torpedo, and it drills under your driveway and pops up the fiber in front of your doorstep. In the third picture, you see my doorstep. At the end of 2021, they plan to bring the fiber inside of my house, only they had a small issue that I have a doorstep of 1 meter with concrete, so they can't easily drill under my front door and bring inside the fiber. So I told to them, you can use the duct where the power pipe is laying in. Otherwise, they will bring it in my living room, and that is something my wife don't like, so I want to have it in my meter cupboard. And they said they agreed, it's good, but you have to make the hole in that power pipe, in that duct, so we won't do that because it's a big risk. And well, yeah, it's only 1 day before Christmas, so what possibly can go wrong? So I drilled the hole in it, and yeah, it was one other issue. The engineer only had 1 hour of time to bring inside the fiber. So after 1 hour, I made the hole. He tried to pull in the fiber, but it didn't succeed. So that day at 4 o'clock, he called in some senior engineers. So at 4 o'clock, they were helping each other. And after a couple of minutes, the senior engineer made it inside my house. So finally, yeah, I got fiber to the home. And 1 month later, the connection was actually activated. So yeah, I had also my gigabit connection. Yeah, there's something about different network technologies. The first fiber to home projects were mainly point-to-point. And point-to-point is a very common technique. It's just you have a switch in your area pop. The area pop is where all fibers come together. So you have a switch, and every customer has his own fiber connected to a port on the switch. So that's very easy, very common. The switch is an uplink to an aggregation switch or router. Yeah, and it's very easy for the provisioning. You know what customer is connected to what switch, so you can easily provision the profiles and the settings. Another technique that is currently used a lot in the Netherlands is the PON technique, and it's called passive optical networking. Yeah, the big difference with this technique is you don't have a switch in your area pop, but mostly you have splitters, and those splitters split the optical signal in, for example, 32 signals or even 64. And those splitters get fed by a so-called OLT, optical line terminal, and that's the device that sends the light on the fiber. And mostly that's this OLT device, this central switch, is located centrally in the city pop. So that's mostly one pop in a city. Yeah, and the big advantage of this option is you need less active equipment. Yeah, and it's a shared minimum. In this picture, you see a technique where there's made use of a cascading splitter. So first you have a 1-to-2 splitter that splits the feeding signal from the OLT in 2 light signals, and after that you see a 1-to-32 splitter that splits it into 64 signals. So with one active port, you can connect up to 64 different ONTs, and those ONTs are located at the customer side. Yeah, and why should you choose XDS PON if you can also choose point-to-point? The first topic, the flexibility in layer 1 network. With point-to-point, you are not so flexible. Most optics that are used, the BD optics, only can go up to 10 kilometers. So in every area pop, you have to place an active switch, an active device, because the reach is only 10 kilometers. So you need a lot of active devices, and you're not so flexible in how you build your whole layer 1 network. With PON, you have some more options. And one example is a project I did with my previous employer. That was in the Noordoostpolder. We built a network, and the challenge was, you have very large distances. For example, a lot of farms far away. And in this project, we made a design that we could lighten up the whole Noordoostpolder with only one active device. So with one active device placed in the city pop in the center of the region, and we had some small area pops that contained the splitters. So we only need one active device, and that's very economical and also very easy to manage because you have only one switch, only one device to manage. And also we could even reach up to 40 kilometers. So the farm that was far away in the north, we could reach a span of 40 kilometers from one active port on the central switch, the OLT. The other thing, it's very important for the telco, is the cost per port, because you have, with one active port, you can connect up to 64 or even 128 customers. You need a lot less active ports. And also, yeah, the active ports are more expensive than the cheap ports you have on the splitter. A splitter is just a dumb device that splits signal, and yeah, it only costs 100, 200 euros. So that's not so expensive as a whole switch. Yeah, and one thing that is maybe point-to-point, a bit better technology is the oversubscription. With point-to-point, you have a dedicated 1 gigabit connection if you have 1 gigabit ports, or even 10 gigabit. And with PON, you are sharing the bandwidth. So, for example, GPON is 2.5 gigabits, and you share it with all users on that same port. With XGS-PON, you have 10 gigabits symmetrical, and that you share with the number of customers you have on that splitter that's connected to that device. So, but if you have 10 gigabits and you share it with 64 people, well, I think it's enough for the coming years. And last but not least, power usage. I think nowadays, you know, the power prices are increasing very fast. I think that's a factor. It will get more and more important because with PON you have one active optic that can lighten up to 64 users, and if you compare it with point-to-point, you have needed an optic in an active device for every user. It can save you a lot of money. I did some calculations, and with the 2 million target Delta Fiber has, it goes up to several million euros per year you will save on only the power cost. So I think it's a very green technology. Yeah, then something about the optical side. Yeah, you have to know with fiber to the home, every customer gets a simplex fiber, so it's not duplex fiber where you can do TX, RX on 2 different fibers. So it's simplex, so you need a technique to get that signal up and downstream over 1 fiber. And what they use is they use different wavelengths. And I've shown a picture here. Point-to-point and GPON use the same wavelengths normally. So that's 3010 for the upstream, 1519 for the downstream. One of the reasons that, for example, it's better not to choose for GPON, if you have a current network of point-to-point, you have to know Delta Fiber did point-to-point till last year, and we have a lot of point-to-point customers. If you would do GPON, you can get some issues. I see some issues that with a new GPON network was deployed, and there was also a point-to-point network in that same city, and there was a user that was, that had his GPON connection was brought up, and he thought to be smart because his PON modem wasn't arrived to connect a point-to-point device on a GPON network. Yeah, that's pretty fun because you are connecting the device and it will send a light on the same wavelength as the GPON wavelength uses, and then you will get some interference that all your neighbors will go down. So connecting point-to-point devices on a PON network, it's not so smart thing. And one of the reasons also XGS-PON is very nice. XGS-PON uses a different wavelength. It uses 1270 and 5077. So you can easily deploy that next to a point-to-point network, and you won't get issues if a user connects his old point-to-point device, his old modem, on a PON network, an XGS-PON network. So it's just a different wavelength, and XGS-PON won't see that different wavelength. Yeah, the next step is NG-PON2. It uses even different wavelengths, other wavelengths than XGS-PON, so you could easily upgrade your network from XGS-PON in the future to NG-PON. NG-PON can go up to 50 gigabits, even 100 gigabit. And you can easily upgrade it on the same fiber. You could send an XGS-PON signal and an NG-PON on the same simplex fiber. And by connecting another device, it will pick up only its own signal. So you can roll it out in parallel, or you can upgrade while you're still using XGS-PON, you can upgrade to NG-PON. Yeah, then something about the techniques that are used. First of all, the upstream, I talked about it. It has its own wavelength, 1270. But because you are dealing with a shared medium, what you need to have is some time division multiplexing technique. So I've tried to make 2 diagrams to show that. What the first diagram and above is about the upstream. Every ONT, when it gets online, there's some ranging mechanism going on. So the ONT sends a signal, ONT responds, and the ONT calculates what's the actual distance and latency in microseconds precision to know and to tell the ONT what are your time windows you are allowed to send traffic. For example, if the ONT 1 and 2 sends traffic on the same time window, you will get interference, you will get not the right signal you're expecting. So the ONT tells to the ONT 1 you have to send on this time frame, ONT 2 on that time frame, and if they honor that standard, then they the traffic will arrive sequentially on the OLT. So it's very important to have a good arranging mechanism. The downstream is the opposite. It's just broadcasting. So in a downstream direction, for example, if ONT1 wants to have a packet, the OLT puts the packet on the line, and that packet will arrive on all ONTs on that same splitter. But the ONT looks at the header of the packet, and the header, there's some header in it with some ID that the ONT knows, hey, this is my packet, I grab it off the line and I send it back to my CPE or other device that is connected. But that's not the only technique that is used. One of the things I've done is that it's very strongly advised to have also encryption. For example, if you would sniff before the ONT, you could see the traffic of all users on that same splitter. So if you didn't encrypt the traffic, you could see the traffic of your neighbors, and that's not something you want to have. So there's also some encryption mechanism in place for the downstream. So the ONT sends an encryption key to OLT, and OLT encrypts the traffic with that key, and only the ONT that knows that key can decrypt the traffic. So yeah, it's not meant smart to deploy an XGS-PON network without some encryption. Yeah, and then something about the activation process. Because there's a shared medium, if a customer connects a new device, a so-called ONT, you don't know who connected the device. You don't have a dedicated active port per user, you have a shared port. So what is happening is if there's connected a new ONT, the OLT will get a so-called ONT new alarm. In that ONT new alarm, the serial number of the device, the ONT you connected, is in there. So the OLT knows, hey, this device is coming online. And because Delta Fiber has some sort of pre-registration process that every ONT that is sent to the customer, we register the serial number in our systems, and we have there also the different services the customer wants. So if the customer connects the device, we see that ONT, we make a match in a database, and we will provision that connection with the right configuration. So it's very good to have a very right logistic process, otherwise your neighbor could get the services you want to subscribe. So the logistic process is very important. And last but not least, we have a free modem choice. Like there is a law that says that every user has the right to connect his own device in his house. So we have to deal with it too, Delta Fiber. So we have the option, if you want to have your own device, you don't like that box that Delta Fiber delivers, then you have the option to buy your own ONT. And but before you can activate it, you have to give the serial number to us. So you can give it to us, and we will register the serial number. And then hopefully, if the device matches what we expect, it will get provisioned. Yeah, and then something about installing all those OLTs. You have to know Delta Fiber has a big ambition, so they need to install hundreds of OLTs. Every week, a couple of these devices get installed by contractors. So we have built some automation process for it. It was one of the biggest projects I did last year. So first of all, we have chosen to deploy a new CMDB system. We've chosen for Nautabot. I think it's a very good choice. It's a fork of Netbox with some additions that you can easily create job modules. And job modules are easy wizards for creating new devices. So a contractor can easily create a new device. He only has to say, I want to install a new OLT at this location with this host name, and everything is done automatically. So the management repeaters are created from a pool, interfaces are created, all kinds of stuff is created in Nautabot. The contractor places it on plant. He has to plan to install it, for example, next week. And after he goes to the POP, he installs, he racks up the whole thing, he connects all the fibers. He only needs to change the status from planned to installed. And when he places it to installed, our whole provisioning process is starting. So and we use the API from Nautabot to get all the information. And we have also a nice intent-based networking system that has some APIs, and all the right APIs are called, and the whole configuration is provisioned. So then you have a new OLT that's fully compliant to the templates you specified. And I think that's very important. Otherwise, you will get different configurations of different OLTs, and it will get hard troubleshooting that. But I had still to do some CLI magic and SFTP magic. For example, the software that is copied to the ONTs is also on the OLTs, and the intent-based networking system of Nokia didn't have an option to upload the software, so I still had to connect via an SFTP connection to that OLT and upload the right software. So still had some custom things to do. Yeah, then some tales from the trenches, some things we did encounter during the whole project. Yeah, the first thing I discovered was an issue. We had an ONT that didn't succeed to register itself, so it stayed in some initial state and it didn't register correctly. So I thought maybe a reboot mag good. So I sent a reboot signal on the PON line, and in that reboot signal there is a serial number, and the serial number was a serial number of the ONT I wanted to reboot. So that signal was broadcasted to all ONTs, and normally only the ONT that has that serial number needs to pick up the message and needs to reboot itself. But when I sent the signal, all ONTs got rebooted on that port. So I created some impact that I didn't expect, and it appeared to be a bug on the ONT. So the ONT just saw that reboot command coming in, and it didn't look at the serial number. So all ONTs just rebooted. That was not good. But the vendor that, saw it. I filed a ticket, and he fixed it in the next release. Another thing I discovered during the project is that some ONTs had memory leaks. And I discovered it by using some Grafana graphs. What I did is all ONTs report their state every couple of hours, every hour, to an ACS server. It's a TR069 server. And the TR069 server sends some metrics to some central influx DB, and I created some graphs of it. And one of the graphs I created was a memory-free graph per OLT. And you can see in a picture, most ONTs are stable with memory usage, but a couple of ONTs still every time decreases the memory usage, and they crashed, and then it goes up, goes down, goes up. So I filed a ticket at the vendor, and they saw it was a software issue, and that software, they fixed it. So. And last but not least, my colleague Maurice has a good, he bought an XGS-PON optic somewhere from the internet, I don't know exactly where. We connected it in the lab, luckily it was not production, and after he connected it in the lab, all ONTs on the same port get interrupted. They went down. So yeah, think before if you connect some optic or some third-party device on an XGS-PON network, it could generate interference. So yeah, it's good to watch out. And that's also one of the things of PON. The ONT and the OLT, yeah, they talk a lot together. So the ONT needs to comply to the standards. And if an ONT does strange things, it sends traffic in wrong time windows, you can create impact on your neighbors. So yeah, if you want to have a good relationship with your neighbors, watch out. Yeah, finally, some conclusions about XGS-PON, about the whole designing and implementation. I think XGS-PON is a market-ready technology. During the whole POC phase, testing phase, I test every feature like multicasting, VLANs, trunking, IPv6, all kinds of things just worked out of the box. So yeah, I didn't have any issue on the OLT side, so the centralized device in the POPs works perfectly. There wasn't any bugs I discovered during the extensive testing. The most issues I've seen was on the ONT RG side, and especially on the RG side. Delta Fiber delivers a combined device for the customer, so it's an ONT, and that does the optical translation to Ethernet, and we have an RG side, that's more the thing that does NAT address translation, Wi-Fi, VoIP, and the whole shizzle. And the most bugs I discovered were all on the RG side. So yeah, there's a lot of software going on, and yeah, you have to know those boxes cost under the €100 or around €100, and it has to do everything you can imagine. So yeah, you can imagine that if you pay less to the vendor, yeah, maybe you will get less quality. But yeah, so that took us a lot of time to find these bugs and let them fix them. And one of the things I also discovered is the monitoring is very important. So not only your equipment in the POPs, but also the equipment at the customer side. So it's very good to do continuous monitoring of all the devices you have in the field to see if there are issues popping up. You can test everything in the lab, you can test a lot, but always if you go in production with some CPE, with some ONT, you will always see that there are bugs you didn't see in the lab. So I think it's very good to monitor it, and also after every firmware change, keep monitoring what is happening. But for automation is key. If you plan to install a lot of devices, I think it's very important also for the speed of deployment to have automation, but also of the consistency. If you don't automate and you make some workbook, you know every engineer has his own interpretation or will do things strange other than the workbook. So I think automation is key to have a very good managed and well-deployed network. And last but not least, speeds up to 10 gigabit are achievable. So this is a screenshot of a test I did 1 month ago with a new CPE we are testing. And I think it's very impressive. I did some speed testing and the vendor promised, it can do up to 10 gigabit also through the NOT engine. So I thought, you say it, but I want to see it. So I bought some test equipment, and it was some professional test equipment. I connected it at the LAN port of the ONT, and the vendor was right. I could get up to 8.5 gigabits via my testing device. So it was very impressive. Also one thing to state is, you had to have some professional equipment. I tested also with some laptops, but it's very hard to get that 10 gigabit with the current equipment that's in the market. So you need some professional equipment. That was my presentation. If you have any questions, please go to the microphone. And if you have questions you want to hear, you can also contact me offline later, or you can send me an email or ping me on IRC.
There are a lot of questions, it seems. I would like to ask to keep them a bit short in the interest of time. Rudolf.
To connect with my presentation, do you see too much traffic on your network, and can you financially handle it?
Thank you. Over there, I cannot see you well because of the light.
Sorry, can you repeat the question? I didn't exactly hear it, but sorry, but No, I don't say it.
I wondered whether your network can handle the traffic that you're currently seeing and whether it's financially affordable in line with my presentation.
No, I think our traffic is overloaded right now. Yeah, true. No, it can handle it perfectly. So we don't see any change by installing a new technique. It's just by installing XGS-PON, it's not that the user is generating lots of traffic, more traffic than it normally does. So no. Okay.
All right.
Next question.
Next question, please.
What are your plans for allowing third-party vendors onto your network, and where would you connect them?
There is a law legislation, there is a rule we need to accept other CPEs. So if you are a customer, bring your own device, we have to support it. So
no, not the CPE, other parties than Delta Fiber.
Okay, other parties, it's maybe a bit more commercial, but what I can say, this network is built as a wholesale network. So we have currently, I think, about a couple of, up to 10 wholesale parties, but the network is built. We could allow other parties to deliver services, but I don't know what currently is the whole wholesale offer we do. But the network is technically built. We can do wholesale for a lot of different wholesale customers.
Okay, but then the interconnect would be somewhere in a data center in like Amsterdam, and then you traverse your entire Delta network, ONT, that would be all the same.
Normally for wholesale party, you will interconnect at 2 points in Amsterdam, and we will transport the whole traffic to the network and the customers. That's the normal way of doing this, true.
Yeah, because in point-to-point networks, what would happen is the other vendor could choose to be in the POP and build their own ring and that sort of, but that with PON, that's not going to happen.
That's also possible. They call it ODF access. I don't know if Delta Fiber does that, but it's only interesting if you are a very big party that wants to do wholesale and wants to have your own equipment. But I think that's something for the commercial people to decide if that's allowed. I don't know exactly if it's mandatory that we need to provide that access, but maybe it's more something you can ask Rudolf.
Thank you.
Okay.
I'm afraid Joris is going to be the last question. I'm sorry.
If there are more questions, you can talk to me during the lunch break. So.
Sorry for stealing the last question here, but my question was actually related to third-party devices as in ONTs. So as you need to allow third-party devices to be present on the network, and you identify the risk of, well, XGS-PON transceivers being able to break the whole path, how do you plan to mitigate that?
Yeah, that's a good thing. Luckily, it doesn't happen a lot. Most people just use the normal box we send. But yeah, my choice would be, and I've talked about it with Rudolf, is that you have also that ONT device. It's a very simple device. It just converts the PON signal to Ethernet. And I would have preferred that, that we just use that device and that we connect a different CPE behind it. Because most users that want to connect their own Linux box or own fancy device does have an Ethernet uplink. So I would have preferred that we went for that solution. But yeah, it's a risk, but it doesn't happen a lot. And most devices we had tested with some other vendors, and most of the vendors have a good standard and it works. But yeah, if you buy some optic from China, yeah, it could be you break the connection. But yeah, that's a risk too. Yeah.
Okay. Thank you.
Thank you, Rinse. We have a small present for you.
So we're switching microphones now because instead of being the host, now Niels is going to present together with Frans. So please, Frans, join us. Well, in one of the earlier presentations by who was around as a network engineer in 2002, and a lot of hands were shown, and maybe that's becoming a bit of a problem for us because we need to find new talent because somewhere in the future, we will be old and gray and in a retirement home, and someone will need to fix our internet. So how are we going to do that? And that's what Niels and Frans will be talking about. So please give them a hand.
Thank you. Yeah, to be honest, I do not claim that I have all the answers about this. I just hope that I will be able to say a few words that might inspire people so that they can also do something to make this happen. Because what is the issue? Well, if you look around, look around now a little bit, please. This is what you looked like 4 years ago. Can anyone see the difference? The only difference, I think, is that everybody became 8 years older. For the rest, everything is still the same. Now, well, it's not completely the same, but the issue is we want to find younger people who want to be in our community and whom we want to trust to give them configure or enable access on our AS. And how should we do that? If we stay like this, then in 4 more years, we will all have grown 8 more years older, and it will still look the same. Well, as many of you who know me a little bit will already know, and others have obviously already inferred from my athletic posture, I have been involved in competitive swimming for basically all my life. And if you look at how this is set up, there is the bond, so basically the big union of all swimming clubs in the Netherlands, and they have a plan. They tell you that if today is 2022, and in the Olympics in 2036 we want to be there with 8 swimmers, then until a year or, well, we need to have 800 kids join a swimming club every year. And that is something like what is happening here. If you want to finally find that right talent to get your enable or configure access, depending on your favorite brand of router, then we need to get into this right now and get many people interested in what it actually is that we do. Now, fortunately, I don't think we have to do all of that ourselves. There are great schools that have IT departments where students can learn about anything IT. I think many of them choose things like game design or business something or other. we need to be sure that they get into networking as well. Well, what I do myself is obviously, as you all know, I'm the owner of Fusix. This mess here is one project that a stagiaire, an intern, once did for us. He was trying to find the right router to use in a certain project. And that was his internship. It worked. And we basically still, for this kind of purpose, use the same kind of router that he researched. So that's good. And we had other interns. But there has almost not been a time in Fusix when there has not been an intern. So this guy was at an HBO level. We had a guy at MBO level. And for him it was more like learning how to work, so that you have to get to an office every day and that you have to interact with people, that sort of stuff. And we got him interested in Linux, and in the end he made his own Minecraft server and all his friends were jealous. So goal was met. And we had another intern who built a substantial system for us, and that was at HBO level at the time. The guy also has his master's now, and we hired him again for a new project just now because we are so happy with them. And I would like to urge you, if you have the possibility in your company, take those interns because they can really do a good job. I admit they can also not do a good job, but it's up to you to get them to do the good job. And it costs you some time, it costs you some money, but you do get results from it. Please do it. Another thing that I personally do, and I took this from the website of the Hogeschool van Amsterdam, is that I act as like an extern deskundige. So when there is a new student who needs to graduate, then I join the session. I read the thesis beforehand, usually twice, just to make sure. I jot down some notes, and during the session I will ask some questions and basically confirm to the school that the whole thing is up to modern industry standards. And this is a few times a year, and it costs you a few hours per session. You learn something about a subject that you may not be dealing with every day, but you do learn about it. And it even gets me some business every now and then with the company that the people worked for. And I also meet Frans there every now and then, so that's also a good thing. One more thing I wanted to mention before I give the floor to Frans is that you guys are here today, which we all love and appreciate, but I am a little bit afraid that many of you have had to take a day off to be here. It is something that I read in IRC, it's something that I hear from people. You know, the first NLNOG day ever in 2014 or 15 was on a Saturday because we wanted to be sure that everybody could make it. But by now, I think it is more professional, though I still hear that many people have to take a day off in order to be able to visit this day, so that's why I have a holiday picture here. We hope that this is not going to be necessary. The only thing that we have done about that so far is that we have a page on the website that explains why you should attend the NLNOG Day. I would just like to ask if there is more that you think that we can do in order to make more new people show up to this day, then please do let us know, because we do feel that this is important. This is basically what I wanted to say, just a few small things that I do that might serve as an inspiration for all of you. Frans has taken it up quite a bit, because, well, he can say it himself, but it's not just that he acts as the externe deskundige at HBO's, but he's basically just built his own school. Frans ter Borg.
So good afternoon. Well, I'm not sure I quite agree with Niels. I have put in a lot of effort, but it hasn't just been me. So I'm Frans ter Borg. I'm the founder of Kwanza, which is a company that designs, builds, and operates networks and server infrastructures in societally relevant environments. We run the NOG for the M6. We run the SURF network operationally, and operate the network for the GVB, the Amsterdam Municipal Network, amongst others. Some time ago, about 7 years, I was asked to join the board of ISP Connect, which is, or was, an industry association for hosting and cloud companies. Not because we run our own cloud, but because we, I know a lot about the industry and I thought I could be helpful. At some point, we were discussing the influx of new personnel. 7 years ago, it was a problem as well. I raised my hand when the question was asked, who wants to be involved in this project? What happened is we ran into a gentleman, Marcel Schilders, who had been involved in setting up, we call it dual educations. In his past, it was mostly around construction and engineering, civil projects. But he was keen on getting involved in the IT industry as well, and we created a foundation, the Cloud IT Academy. Because we said, okay, we want to make sure that we start an influx of new blood, if you wish, into our community. Yeah, how better to do that than to get people from schools to join, rather than just fish in the same pond, bid up against each other and make, well, a lot of problems. Where we are now, so the program's been running, we're in the 5th year. We currently have 135 students in the program that work at 60 cloud and hosting companies, some infrastructure companies like ourselves, who are working their way up from the MBO level, which I think translates into secondary vocational education, level 4 education. That's where we recruit them. We recruit them at MBOs. And a lot of these MBO students, they're not sure what to do as a next step. HBO, another 4 years of studying, sort of deters them. They don't really want to get into that immediately, at least not all of them. They want to work. However, they also say, maybe I want to get that next paper, that next diploma, and how can we sort of combine that? So what we did is we did a search. We went to some bachelor level education institutions like the Hogeschool van Amsterdam, who said, well, we already have 1,100 students starting each year. We don't even know where to put them. And we are happy that in January, 50% will have quit, so that we have a spot for them in the classrooms. So they didn't want to join forces. Rotterdam, they didn't have the money nor the teachers, but when we went to Utrecht, which accidentally is a very central place, which made our lives easy in a lot of other aspects, they said, what a good idea, we want to invest money in this, we have teachers, we have money, please go on and set this up. So what we're doing from the foundation, from CITA, is we are, as I said, recruiting students at the MBOs. We do that by going into the MBOs at fixed times, especially around the times when the students are looking for either internships or when they're close to finishing their studies and want to decide on approximately 30 MBO institutions give well, lectures, if you wish, about the CITA offering, about the companies that we work with, to try and make these students join our program. And when they tell us that they are interested, we go and introduce them to the companies from our community. So yeah, doing that, we look at the region where the students come from. We try to find a company somewhere in the neighborhood. Our sort of area that we cover is about 100-kilometer radius around Utrecht, because that's where the students sort of have to go for their studies. The whole thing is, the study is dual, so the students work 3 days a week in a professional environment. They go to school 1 day a week, and they do 1 day of self-study. This requires quite a bit from the companies as well. The companies have to sort of make sure that there is work that is appropriate to the tasks that need to be done for the studies, so that you really need someone inside the company to guide the student, to help them find projects, to define projects, to make sure that they can get their study points. Then as the foundation, we coach the students on the job, we coach the people in the companies that guide the students. And well, again, as I said, it's a very successful program so far. As I said, 34 MBO locations that we do. There are more in the Netherlands, but simply the travel time to Utrecht for the students is a thing that we take into account. So we don't restrict students coming from further away, but it's just impractical. So we try to make them move if they really want to join. The population that we're looking at is about 3,000 MBO level students, level 4 students, that we try to reach every year. And roughly 200 students express an interest, leading to roughly 75 to 100 sort of actual encounters. And this year we started with probably 60 new students in the program. And we're aiming for 75 new students next year. The study in Utrecht is the what used to be called SNE, System and Network Engineering, which was later rebranded as a very hip and cool studies, Cybersecurity and Cloud, which is essentially still the same study. But perhaps with a little bit more focus on cybersecurity and cloud. From our community, we are able to influence the class content. I think that we're probably, within the Netherlands, the most current bachelor education, which is most in line with whatever is happening in the rest of the world, or at least in our world. Specifically, an example for ROC Midden-Nederland, which happens to be close to the Hogeschool Utrecht. So yeah, we give guest lectures for the students. Some of the companies from our community give lectures, or it's me or our director. We have a CV generator that helps the students to present themselves to interested companies, and we do matching, arrange for interviews and what have you. Again, we coach the students on the job for 4 times a year. They have a talk with one of our coaches, and we look at how we can make their learning experience as best as possible. So this is an actual bachelor. It takes 4 years, so it requires quite a bit of effort from both the student, but also from the company, who needs to give the handle the student and give him space to actually finish their studies. We're continuously fine-tuning the program, but things are going, again, really well. I'll skip this, as we are also close to lunch. Some practicalities. If we recruit a student, we promise the student that the company that we will place him at will pay for his tuition if he does attain the 50 sort of study points credits And that the student will also be reimbursed for his books and whatever other training materials. We also ask and promise to the student that he will get a 4-year contract and a salary. We give some guidance on how high the salary could be. And that the company will give him room to actually do his studies. There's also a 3-party contract involved there. Some other numbers, because I'm also sort of trying to get you in. We charge from CITA a 3,500 euro fee per student per year for the actual coordination, and a yearly membership of 1,000 euros. And most of that can be retrieved from the RVO through a subsidy praktijkleren, but the actual number for the subsidy differs per year, so I can't make any promises that you will actually get everything back. Some timelines. By now, we will be starting the recruitment of interns at MBOs. Essentially, as a sort of trial, you can define internship projects for MBO level students, MBO level 4 students, and sort of try out a student for a while. And we will try to make that student interested in joining the program at the start of the next school year, which will be in September 2023. So the actual recruitment for this internship is happening now, and it will be January, February that the actual internships will start. Again, for the tryout of the student. I mean, you don't know what you'll find, and perhaps you will decide, okay, hey, this guy isn't just because this isn't the good sort of character, I don't know. But hopefully you'll find someone that fits your culture. And then from March next year, when the students are actually really finishing their studies, some of them may not have heard from our program yet, or sometimes they are at an internship that they don't want to stay at. So we'll engage again. We'll find students for joining the program, and we'll match them with job positions that you have published. And we hope to start again with 75 students next year. So this is for CSC, Cybersecurity and Cloud, and since 2 years, and next year it will be the 3rd year, we also have the same program for software development students, which is somewhat less successful, but we started in COVID time, so we're hoping that next year we'll have really picked up, and it will be at sort of the same levels with 40 to 50 students joining. This is the bachelor sort of program, the topics that they'll learn, but it's dynamic. So there's organization, there's stuff about compute, about operating systems, there's stuff about networks, which is clearly more why we're here today, but I think it's most of the students will fit in organizations, in most of your organizations. And it's also good to sort of know more than the network. It's always good to know what is connected to your network, how to deal with security and stuff like that. So I'd like to invite you to, if you're interested in joining the program, either reach out to me or to our director, who would have normally been here, but she's attending a wedding in Italy. Reach out to us. We can provide you with more information. Clearly, this is only for the Netherlands. It's about the Hogeschool Utrecht, but perhaps this will inspire you if you're based in a different country to set up something similar. Any questions?
Any short questions, please?
Yes, darling. For one, we all know women tend to have a lot of interest in learning technology before they're 14. So when you are in the MBO, the interest of women deteriorates. So I have 2 questions. One for you and one for Niels. what are you doing to get the attention of the young girls? And 2, when are we going to have a Kids Day and NLNOG Day? No, I'm not shitting. My little girl actually asked me this morning, I want to go. And I told her no, because she's 11, but she's already really interested. And if I can get her into networking, that would be an awesome opportunity.
That is a great idea, and we will take it on.
Thank you.
Yeah, to address your question, I think it's a very fair question. When the foundation was started, we had limited means. And in order to reach success pretty quickly after, we thought that the MBO4 students would be the best way to start, and it has worked for us. It's still so that we don't have a lot of money as a foundation. And in order to reach the 14-year-olds, we have to sort of go from 30 MBO education institutions to probably several hundreds of half of VWO.
I can get you one already to start with, a primary school in the neighborhood. Just try a version there, and maybe you will get some success in moving into MBO, HAVO.
What we're doing is we're trying to get subsidies, more funding from the government as well, who are seeing that this program is actually working. We're being mentioned as an example at VNO-NCW, for example, which helps us in attract extra funding and grow the organization to get a better reach. But yeah, you're right, it's a slow process.
If I can help.
An excellent prequel talk to my 2019 talk. Thank you. I noticed, looking through the slides, that there was only one woman pictured. She was pictured twice, so it's plausible she's got a twin sister on the course. But what is your gender makeup of the 135? Because 67.5 should be women. What have you got?
We're, again here, dependent on what the MBO supplies from the guest lectures that we give. I think that there are probably 6 or 7 ladies in the program out of 135 at the moment. And that sort of, yeah, we should go back to your, to the other lady that was just asking the questions. We should make sure, all of us, that we get more ladies interested, absolutely.
Thank you. And thank you, Frans. We have a present for you, as we do for everyone. I gave only a small presentation, so I get a small present. Before we can go to lunch, I hear you. During lunch, if you sit outside, you can order drinks through the QR codes. It's a little flashback, but they will be brought to you. So that's pretty cool. Technology. Before we go to lunch, this is Thomas. He is our treasurer, penningmeester, and he has an announcement for us. It's not that all the money is gone.
So that's the good news. But I decided to stop as a NLNOG board member. Yeah, I've been treasurer since the beginning of NLNOG Foundation. Now, thanks. And yeah, we founded it in 2015, January. So I can still remember that part. And I enjoy it a lot, but I can no longer combine it with my work and my family life. So Zonne has supported me with a lot of work in the recent years. Thanks, Zonne, for that. So we'll probably also received a lot of emails from Zonne. But unfortunately, Zonne is as well too busy to continue this work. That's why we now have a new vacancy open as a treasurer for NLNOG. So if you are interested, let me know. Come to me and I will tell you more about it, explain you. I will not leave until the end of the year, so I will still do the financial closing of this year, and as well help the new treasurer to start up. It was a great time working with these amazing and passionate board members. Thanks for that. I will definitely gonna miss it. And thank you for your support and all the donations. So thanks.
So everybody get in line to apply for this job and talk to Thomas. Now it's finally lunchtime. There are a few people who ordered something special for lunch. If you have ordered vegan, cheese allergy, lactose intolerance, peanut allergy, or no lactose and gluten, then you can get your lunch at the bar. If you had any other dietary requirements, then you can join in the normal lunch, because nothing that's in there will affect your diet. I'm not sure what will affect my diet, but we will see. So we have decided that we go 15 minutes later. We come back here, so we see you again at 2. Enjoy your lunch. Robin hebben we ook, toch? Robin hebben we ook. De microfoon staat aan. Je zet het zelf op YouTube. Onder havenklap. De laatste hoodie? If you want to still get a hoodie, buy a hoodie, then do it now. But otherwise, I would like to ask to take your seats. So welcome back. I hope you enjoyed lunch. And here we are for the second part of the NLNOG day. afternoon part. Ever since the very first NLNOG Day, which was held in the office of Publitas, with about 60 participants, the day has been streamed and recorded. And as we have all seen, that's something that always works flawlessly. And there has been, for all those years, one company responsible doing all this. And when we produced the COVID editions of NLNOG Day 2 years ago, it was basically a TV show with remote presenters, and it was absolutely amazing that it was all ran from the living room of this lady, who was connecting over the internet with video to all the presenters and was also communicating with them, and she was switching around between the host, the presenters, Q&A, and that went fantastic. Well, I have learned by now that if you have all the presenters locally, it is an easy project. If you have all the presenters remotely, it is also easy, but if you mix the two, it can be quite hard to make the whole day come together. But anyway, we thought that you might like to know a little bit about how this is actually done. So we asked Denise to give a short presentation about how they actually do this. How do they make this stream and make this one TV show? Denise will present. And she has said that she prefers not to take questions and go behind the black curtain as quickly as possible. So if you do have questions, save them for the end of the day, please. Give it up for Denise.
Hi, I'm Denise. I'm from Global Media Productions. And last year, Natalie came to me and said, well, 20 years of NLNOG, wouldn't it be funny to do a behind the scenes? Yeah, but I'm working behind the scenes, literally behind the curtain. There's a reason for that. I can send you a video. Natalie thought and said, well, you can do a video, but you have to announce it yourself. So here I am in the spotlight, far out of my comfort zone. Woohoo! The behind the scenes. This is what you see literally behind the scenes right now if I take away the curtains. Well, not really that, because I'm right here, right now. My stage fear. So this is my husband. And my husband is still behind the curtains. He's our broadcast engineer, and he knows everything about the technology. So we had a little error this morning, and he came up and he fixed it.
I think I see a loop there.
Sometimes it's a challenge to find the right cable. He can also do the shading, making the colors right and bright, so that everybody looks healthy instead of a green alien. And sometimes it's on the scene itself. He can also be the cameraman. He is always my man. So this is me. I'm the remote camera operator. We have today 5 cameras you can see and 1 behind the stage. I can also be the producer. This was last year here at Podium Mosaic. And I'm always Lindsay's mom. Maybe you know Lindsay because Lindsay is the girl on the stream the night before the NLNOG. She has to test the live stream, but to test the live stream we have somebody who needs to talk in a microphone with no stage fear. So we can put all the cameras together, the lighting together, and the sound together. This was in 2018. You can still find it on the YouTube. Lindsay had to make some homework and do a book report. She did it on the NLNOG test day, and she put the link to the teacher. The teacher approved it. And sometimes she tries to do something with the camera, but she's just 16 now, so she needs a little practice. So that's me in the spotlight. Now I'm going back to behind the scenes, and my husband will start a video about what we do and how we came here.
Welcome to NLNOG Day 2021. We're super excited to be back in Podium Mosaic again. And we're also live streaming. Also, if you're watching online,
I think we can really jump into the
The last one is to cover all of the this if you how you watch anything. Yes, I like this is the number one. CVL, IPL, IPs.
So that's how they do it. But now they do have to come out because, of course, we have a present. I think Melchior is trying to find the present among some coiled network cables over there. Nee, allebei.
Ja, voor Sven.
Zeg one is enough, niks one is enough. Sven is the one with the real stage fright. When you hear people talk about intent-based networking, don't you think, that's all just a marketing gimmick? So when Robin Gilliamse sent us a proposal to present about intent-based networking, I thought, is he still on the light side? But I think he is, and I think he's going to tell us why he is in his presentation about DIY intent-based networking.
We'll see whether it's light or dark. I'll leave that up to your own interpretation. Okay, so, well, Niels said it all. Intent-based networking is kind of marketing hype. But I wanted to look a bit under the covers, see what it really is, see if it's useful to us. So a little bit about myself, network engineer, automation, at 10IT and Ncubed, where I do probably what most of you also do, help people run and automate networks. In my spare time, you can find me riding a bike or hitting people with foam swords. But before I start, I have a slight disclaimer about my code, my DIY solution. First of all, whatever I'm going to show you, it's non-production code. It is based on a real deployment, but it's not actually deployed code. We built something like it for a customer, and then I thought about it a bit more, and this is more like a thought experiment of what I perhaps should have done for that customer, could have done, and it's based on that. Second of all, don't blame me on my tool choices. I've decided to do everything with Ansible just because. If you want to debate Ansible versus Nornir or native Python or any other tool choice, I'll be at the bar. I'd love to debate it, just not now. And for the third disclaimer, I have to tell you a bit about, well, how I work, what my thought process is. So please allow me a little digression. I want you to talk to you about my smoke sensor. A while back, say about 10 years ago, I bought a Nest smoke sensor, which was really nice because it's smart and it has an app, so I can see remotely whether my house is on fire, and it gives it gives me a good feeling that I know that it's still working, that the battery is okay, because I can see it in my app and I can get an alert from my own monitoring system when it's not okay. So that's nice. Until I started to dig a bit more, and then, well, they took away the API, and it's a really expensive piece of kit. And it's 10 years old, so I have to replace it. And, well, there's a new law that says I have to have many more smoke detectors in my house. So I decided to think about it a bit and see, well, what's actually in a smoke detector. And it turns out it's a bunch of sensors and it's some compute. So, well, I thought about it. Can I do it myself? And sure enough, you can buy compute and you can buy sensors and you can buy a nice LED to put it all together. And it's really cheap, but then you have a couple of components and you have to figure out how to integrate it and then do something useful with it. So I had to learn about a whole bunch of stuff, like what to do with a LED, because you can't just plug it in. And I had to use some low-code stuff and 3D print a case and all the stuff. But it took a lot of time, but it was really fun to learn. And then how to work in smoke detector. I didn't put it in production. I mean, I did put it in production, but I also bought some real smoke detectors because it's safety critical. And I'm not trusting my own soldering skills, just quite yet. So that's how my brain works. And I had about the same thing with intent-based networking. I read about it a lot, I heard about it a lot, and I wanted to know, well, what is it? So let me start by talking to you about IBN. What is it? Well, if you start to look online, you find a lot of marketing materials. And it's really fancy. It's like a smart network that solves all your problems automatically. Basically, the network can run itself. It's magic, which is awesome. And also, I don't think any of us believes it. I don't. Luckily, the IETF is working on, well, what is IBN? And there's a draft, it's actually really close to being a proper RFC right now, about concept and definitions of IBN. That's really helpful. They're defining intent-based networking as a network that can be managed using intent. Which, yeah, I guess, not really helping. Luckily, they define intent, and what they're saying is it's a set of operational goals defined in a declarative manner. Okay, operational goals I can handle, declarative manner, I'm thinking Ansible, but could be anything, that makes sense. Sure, you can do it. All of the marketing slides have something like this picture in it. This is an intent-based networking system, the big blue part, it's IBN system. It takes business logic, which is used to define intent. And from that intent, you can generate configs, deploy to infrastructure, get state from the infrastructure, verify if it still matches your intent, and if not, fix it. That's what the engine, the orchestrator in the middle does. It's the engine that makes sure your network infrastructure, your state, conforms with your intent. And the intent is a translation of business logic. So, like this is my intent for a network. I'd like to have my network conform to this intent. Unfortunately, no intent-based system in the world is going to let you just input this and then it'll magically run your system. Sadly. So this is more like operational goals that you want to achieve. So they are really specific technical stuff that I want to achieve. And the important thing in these is their system-wide policies. So it's never about let device X do Y, but it's about my network should be a leaf-spine fabric. Or make sure the core switch is the SP route. So domain-wide. Okay. So that sounds doable, right? Do I need a fancy, expensive solution from a vendor? I'd like to see it in production first. Well, I just decided, why not do it myself? At least I can learn something, and if it doesn't work, I will know what are the right questions to ask my vendors, so they can sell me an expensive solution. Okay, what did I build? I started with a leaf spine fabric. Why? Because every intent-based networking system in the world is probably starting from leaf-spine fabric. The data center is a very nice packaged system which you can run in and of itself. You don't have to consider all the external connections. And it's very, very predictable architecture. In fact, one of the leading intent-based networking vendors, Juniper, their Abstract platform just now announced they're allowing topologies different from leaf-spine. And there's a whole list of caveats and requirements that you have to match in order to be able to do that. So that sort of makes sense. Then I've got, I've got my intent. These are my leaves and spines, and I have a bunch of configuration, which are all the messy details, which my system should be able to take care of itself. And then I have a verification. I'll check whether there are BGP peers. What I don't have is a closed loop. This is on demo purposes. I want to see every step in and of itself and be able to do every step in and of itself. So there's still a man in the loop, which is pretty easy to automate, which I haven't done yet. And I'm using Ansible to do all of it. There's no Python, just purely Ansible, which hinders me somewhat, but it also makes for really clean code. Leaf-spine topology, pretty predictable. That's a nice thing about leaf-spine. It is predictable. You can create an algorithm to calculate loopback addresses, IP addresses on underlay links, etc. I've got a controller running, which is basically just a Linux server running Ansible, and that's it. My happy state, I'll be happy when every spine is paired with every leaf. That's it. So I'll do a show BGP summary and check whether all my states are established, and then it's okay. If BGP is okay, then there's a whole bunch of stuff that needs to be happening on the background, which should also be okay. The cabling should be okay. The interface addressing should be okay. The IGP should be running. So it's a really good check to see whether or not my system is running fine. I've got configuration, Jinja templates. If you haven't yet learned about Jinja templates, I think you should. It's a templating language. It takes a whole bunch of variables like interface configuration variables, BGP, AS numbers, etc. You combine it with a template, and then it'll generate configurations. Now, the important thing is all these configuration details, all these variables, they aren't my intent. My intent is to have a leaf-spine network, and all the configuration details is just implementation. So I have to figure out a way to get all those variables just from my intent. Intent should be as high level as possible. So on the right, you can see that's it. I've got a bunch of spines and I've got a bunch of leaves, and I have to figure out a way to make them out of band reachable. And that's it. This is all of my intent. And from here, I should be able to calculate, to generate an entire Ansible inventory. Of course, again, using Jinja templates and using Ansible. This will generate all the variables, all the interface IP addressing, AS numbers, all of it, which are then used to generate configuration, push it to my routers using netconf, and then I can verify it, again using Ansible. So I've got 3 Ansible playbooks, 1 to turn my intent into a complete inventory, 1 to turn the inventory into running config on devices, and then finally 1 to grab the state from the devices and compare it to my intent. And that's it. I was kind of afraid that I had a much little breather and show you the demo. So I'll pause it. Say, yeah, to show you what's happening. It's paused now, right? No, it's not. Now it is. On the left side, it's Linux running Ansible. Is this readable? Hardly. It is on my screen. Sorry about it. So I'll take the time to explain it a bit more. You can see me listing my intent.yaml config file, which has one spine and 2 leaves. And on the right side here, you can see my router 1 is one of my spines, and router 2 is my other spine. Is it? Yeah, okay, fine. So what I did is I did a show BGP summary on spine 1, and it says it has 2 connected leaves sessions established. My second spine should not have any BGP sessions because it's not running yet. I did a show config, which is just the bare minimum of config to make it reachable. Yeah. Now, I recorded a demo to make this easy, not hard. And now what I did on the controller is this is my intent verification playbook. It just checks the BGP state, and it shows everything is okay, everything is green. Router 1 has BGP connections with both leaves. That's what it's expecting. Now, off screen, I'm changing my intent. It's just a text file, so I'm adding a spine and a leaf, and I'll show it in a second. Is it running? No, it's not. There it is. So I've added a second spine and an additional leaf. Now, when I verify my intent, it'll tell me that everything is wrong because this. Okay, first I'll parse the intent. You can see I have now more variables in my inventory. There are now variables for router 2 and router 3. Push the config to devices. It has changed every device because I've added a new leaf, so it has to, and a new spine, so it has to add everything. And now when I verify, you'll see that I get a whole bunch of red text because it's expecting BGP sessions between the second spine and all the leaves, and between the first spine and leaf 1, and it's not there because it's taking a while. But through the magic of editing, we don't have to wait a minute for it to establish. And after about a minute, the sessions are established, and when I check, it'll loop back to the end, to the beginning. Then you can see that all the sessions are established, and all is green. So that is a very non-impressive exploding demo of a very simple intent-based network system. Yeah, can I go to the next slide? Yeah. So what does my code consist of? It's got a couple of Ansible playbooks, 3 of them, one to parse the intent, turn my very small list of things I want my network to do, having 2 routers and 3 spines, and then generate an inventory. Second, use the inventory to generate configs and push it to the devices. And thirdly, get my BGP state from my devices and verify whether or not all my spines are connected to my leaves. I've got a bunch of inventory templates, which are the templates used to generate my inventory for my intent, and I've got device templates using the inventory to generate device config. The important thing is that the inventory template, so that's the first step, parse intent, that has to contain all the logic. This is basically the translation part, where it takes my business intent, which is run a leaf spine with these spines and these leaves, and then turn it into something my intent engine can use. If you want to check my code, it's there on GitHub. Just have fun with it. So, summarizing this very short talk, I don't think intent-based networking is as magical as it sounds, which is, on one hand, it's good because it's something we can use. On the other hand, it's not something that'll keep me from being paged at 3 a.m. It's very hard to deliver on marketing promises, but I think it does have its uses once you understand it. And cycling back to where it started, about 5 years ago, Gartner coined, well, they didn't coin the term, they popularized the term. And if you look at their hype cycle, I don't know if you've heard of the hype cycle by Gartner, but they're plotting new technologies based on whether it's hype or whether it's production ready, and they're putting it firmly in the bottom of the trough, disillusionment. So it has not lived up to its hype, according to Gartner. And I think that it's still about 10 years until it's really delivering productivity. I think in this case, Gartner is wrong and right. They're wrong because, you can build something intent-based yourself. There's even an RFC about it soon. They're right because the marketing, it's never gonna live up to its marketing hype. So if you want to debate me on tool choices, yeah, do so, I'll be happy. And if you have any questions, I think we've got plenty of time, so.
So, Rob, to do with your smoke detectors now?
Well, the smoke detector story is just, I rose for a couple of smoke detectors. Intent-based networking is the same. People try to sell me really fancy systems for a lot of money, and it's not my money, I know, but still, I'd like to check first, what's in it, and can I do something like it myself?
So your brain is also intent-based. It's
yeah.
Not to spend money on useless stuff.
Yeah. Well, I don't want to say it's useless.
All right.
But I want to know if it's useless or not.
Good. Any other questions for Robin about smoke detectors, intent-based networking, or how his brain works?
Why Ansible again?
Yeah, well, why Ansible? Because it's easy. Oh, okay. Well, actually, that's a completely different talk, but if nobody else has any questions, I'll jump into it. Ansible is probably the simplest way to get started in network automation because you don't have to actually learn any code. It has its own language, but it's quite easy to learn, and it's quite easy to start doing some useful stuff. So that's why. On the other hand, it has a really long list of limitations. You really will learn to hate YAML. You really, and it is its own language, so you have to learn another language. If you know a little bit of Python already, or a lot of Python already, there are probably better solutions. Ask me about it at the bar.
Perfect. Thank you, Robin. The next talk will be by Teun, And I don't think I have to introduce him. Oh, you introduced me so nicely.
Okay.
Maybe now
Okay. So go ahead.
Nah, you put me on the spot. No, everybody knows you. It's no issue. And what Teun will be talking about are the various tools and projects that NLNOG as a foundation is doing. And in some cases, this is software that we make ourselves. In other cases, this is software that is developed by third parties, and we actually pay for it as the foundation. But in all cases, it leads to very useful tools that everybody who runs a network will be able to use every day. So, Teun, it's up to you now.
Okay, so thank you, Niels. For those who don't know me, I'm Teun. I work for BIT. I'm one of the NLNOG board members, and well, quite involved in all the tools and projects we're doing. I will be talking mostly about the things you probably know, but I'm just doing a recap so everyone knows what we have, how you can use it, and well, basically that. So that's the NLNOG Ring, which has been presented here quite a number of times, IRR Explorer, BGP Filter Guide, and the Looking Glass. Well, you see the URLs here. You can find them on our website as well. Starting off with the NLNOG Ring, which is, I think, the biggest project we have right now. And it started out very simple. You start with providing a shell server in your network, and you get access to shell servers by other networks and all over the world. And that can be useful to debug all sorts of problems. And well, in all those years, some cool tools were built to use the ring. So where are we now? We're well over 600 nodes by now. We're nearly at 500 ASNs. We're in 56 countries, and we're still lacking one continent. I think Martin actually mentioned that last year, but I think it will be challenging to get a node on the Antarctic. So we're still praying. So as you can see, they're all over the world. We have many of the bigger countries covered right by now. And well, you can get a shell server in any network, run your tests, and well, see if there is a problem with your network, with their network, somewhere in between, or something like that. So there are all sorts of tools we have available for that, like Ring Ping, which is a tool to do a ping from many networks to a specific destination. Ring curl, which does a retrieval of a specific URL. Ring all, which basically allows you to do anything on a lot of nodes. Ring trace, which makes nice graphs from trace routes, and SQA. And SQA does a sort of performance monitoring of your ring node. And of course, since it's all our Linux machines, you have all the Linux tools available you could think of, like MTR, traceroute, TCP dump, you name it, it's there. So, well, ring ping, as I mentioned, you can use it just by logging into your ring node and run ring ping with a destination. I chose min-v for verbose and min-n5 to reduce the number of nodes tested. Well, you get a nice output. These nodes are able to ping your destination. These aren't. These are the statistics, and that's it. Then there's a ring trace, a tool I wrote, I think about 10 years ago when the ring just started. And ring trace basically does trace routes from a number of nodes and tries to make a nice graph. And well, if you run it like this, which basically says again, use 5 nodes, min A for ASN aggregation, so you don't look at the IP hops, but you look at the ASNs. Minus B is ignore the broken hops and put it on a paste bin for the capital B. And you get something like this, when you can see, well, the NLNOG ring is hosted at the CLD-IN network. And well, there are 5 nodes which were used to do the trace route from, and well, they have pretty different paths towards the network. One via AS1299, ServNet, NLAX, the two Amazon networks that are used are pretty funny because although they both go via the ASN of Amazon, they choose a different upstream provider for CLDIN, AS6543 and Cogent. So this helps you make a graph of how your network or a specific destination is reachable. Then there's SQA. SQA is a tool that runs on every ring node by default. What it does is basically check every other node rapidly. It just does, well, it's not a ping, but it's a sort of ping. And what it then does is if the number of nodes that are reachable drastically changes, it sends an alert. And it also collects all this data on the website sqa.ring.nlnog.net. And yes, we know that it's a slow website. There's a lot of heavy lifting in the background, and it's not really optimized still. And the SQA side can be used to see if there, well, is a common factor in what possibly caused the outage. So it can spot if a specific ASN is detected to be in the path of all the nodes becoming unavailable. So you can see, well, this specific network or this internet exchange is probably the cause of all these nodes becoming unavailable. If your node detects a significant change in the number of available nodes, you get an email typically. Well, it's a bit like you see here. It tells you which nodes became unavailable. So sometimes it helps to see the country code. As you can see here, the .au indicates that a specific part of the world had some trouble reaching a destination. And well, on the right you see how the number of nodes being able to reach your node became, well, from 42 up to 115 or 56 even in a short amount of time. You can configure your own alerts for this, like you can integrate it in a webhook or something like that, so you can well, automate your network monitoring that way. It can help you detect reachability issues for your network. A few other remarks about the NLNOG ring. Most of them, or I think even all of them, require SSH to access, and they require an SSH agent with agent forwarding to work. So that's something to keep in mind if you start using it. And our advice is always to use dedicated SSH keys for the ring, so you don't mix them with your work keys. If you want to update your SSH keys for your company, you can do that on manage.ring.nlnog.net. There's a file there called SSH keys. If you put a new version of the keys for your company there, wait a few hours, it will be deployed on all ring nodes. If you have any questions on how the ring works, there's ring admins at nlnog.net, and there's #ring on the IRC network. And people are happy to help you there. Plans with the NLNOG ring for the coming time. Well, the big thing we will be looking at is upgrading the ring nodes to a newer Ubuntu release, because 18.04 is now still the standard, and it will be end of life somewhere in, I think, April of next year. So we need to do some work there, and it mainly requires rewriting some of the Ansible scripts for managing on irrexplorer.nlnog.net, an overview for a prefix or a set of prefixes from all your database registrations, your RPKI, ROAS, your routing table information, and, well, suggest information on that, improvements, and point out conflicts. And this should help you to improve reachability of your prefixes, and hopefully eventually also